Let us begin. Let us begin in the name of Almighty, the most gracious, the most merciful. With His blessing, I wish a very good morning to one and all. I welcome you all to the third day of APJ Abdul Kalam Technological University sponsored faculty development program on techniques of disaster management and climate change adaptation strategies, organized by Department of Civil Engineering, MESCE Kuttippuram. Let us start today's session with a silent prayer. Thank you all. Today we have three sessions. Civil engineers' role in disaster management and curbing climate change. Civil engineering for disaster risk reduction and disaster risk management planning for resilient and sustainable society. Now, for smooth conducting of the FTP, I would like everyone to abide by the following guidelines. Attendees are requested to mute their mic and turn off their cameras. Please do not present your screen in between. Questions are to be posted in the chat box. The organizing team will present the questions to the speaker at the end of the session. The speaker will answer all the questions if the time permits. If you need any assistance during the program, please use the chat box. Kindly fill up the feedback form after each session. The link of the feedback form will be shared in the chat box. The live streaming of the program will be available on YouTube. Now I request Mrs. Remya MS, Assistant Professor, Civil Engineering Department, to introduce the resource person to the participants.
Okay, thank you, Fayaz. Am I audible?
Yes, ma'am.
Yes. Okay, good morning to all. It gives me an immense pleasure to introduce and welcome the speaker for today's first session, Dr. M. Abdul Akbar sir. He is working as Assistant Professor in Department of Civil Engineering, NIT Jalandhar. Has completed his BTech in Civil Engineering from NIT Calicut and MTech in Structural Engineering from IIT Bombay. Later on, he pursued his PhD in Wind Energy from NIT Calicut. Dr. M. Abdul Akbar is interested in multidisciplinary research focused on development of new ideas. He has a number of research publications in different journals and conferences. Sir is interested in areas like finite element analysis, composite materials, fatigue analysis, structural dynamics, nonlinear analysis, blast resistant design, smart materials, wind energy, and vertical axis wind turbines. It's an honor and privilege for us to have you in this session to deliver a talk on this topic, civil engineers' role in disaster management and curbing climate change. Sir, over to you, sir.
Okay, thank you for the wonderful introduction. So let me share my screen. Is it visible?
Yes.
Okay.
Yes, sir.
Okay. So let me start the presentation. So this is the third day of the FTP, right? So the FTP is titled Techniques for Disaster Management and Climate Change Adaptation Strategies. So my topic, or the topic of my talk, is going to be bang on target. So what are the roles a civil engineer can play in disaster management and curbing climate change? Okay, so as I was introduced, I am an assistant professor working at NIT Jalandhar since past 1.5 years. So it's all the way north in Punjab, and that's it. So this is an introduction. So already the remaining things has been said about me. So let me directly go into the topic. Now, in the course of the 2-day FDP that has already concluded, you might have got some introduction into the topic of disaster management and climate change. But still, it feels a necessity for the flow of my talk to reiterate certain things, which is necessary to explain what I'm going to talk about in today's lecture. So everything is fine. My voice is fine. Volume is fine.
Yeah, fine.
Okay, because we need to ask this, right? In online system, as faculties, we know we are looking at a black box and we are not in touch with people. But anyway, so I'll give you an introduction. So we all know that natural and artificial disasters, they are something which affects on a large scale. So there is widespread loss, serious disruption in society, and often they require international assistance to cover. Okay, so even if it is a developed country which is having a disaster like hurricane or something like that, even they are in such a vulnerable position that they open themselves to international aid, right? Because you have a huge population of people that is getting displaced and their property and assets are destroyed. So you need to rehabilitate them. Now, disaster management and climate change. So these are the two topics, right, for this FTP and also for my talk. So these are interlinked. So a lot of the disasters which are natural, they are a result of climate change. Okay, and indirectly both of them, disasters and climate change, they happen as a result of human activities, lot of them. Okay, it's not that everything is due to that, but lot of them happen due to human activities and they are interlinked. Now, if you look at any particular disaster, a major disaster, there are four distinct phases for any disaster management. So let us look at these four phases and see what we can do as civil engineers in these phases. So first phase is, of course, mitigation. So you are trying to stop or trying to prevent or even lessen the significance of a disaster, right? So that is the mitigation part. And then you have preparedness. So when you know a disaster is going to hit, so suppose a huge cyclone or a tsunami is formed in the Indian Ocean or Pacific Ocean, news reports are released saying that within 3 days or within 4 days, it will hit the coast of Bengal or Orissa or Tamil Nadu or Kerala. So it gives us a time for preparing. Means not all the disasters will give us enough time. So some of the disasters we had to plan well in ahead, but do what we can within the limited period of time. And the third stage is response. So when the calamity hits or when the disaster hits, what is the immediate requirement of that particular time? Okay, and according to that, we will take the appropriate action, that is response. And finally, recovery. So everything settles down. So now at this stage, we look at what we can do as a recovery. So disaster has come, it has gone. So how will we get back to normalcy as soon as possible? So that is recovery. And the thing is, a civil engineer has a role to play in all the four distinct phases. Because the civil engineer, by definition, he encompasses all the things which is related to common man, right? With the different disciplines, environmental, transportation, structural, so it covers everything. Now, out of all the four phases, what we normally see is that a civil engineer's greatest contribution comes in the last stage, recovery. So what can be done? What are the things that can be done in recovery? Okay, so that is where traditionally in the traditional setup, where civil engineer comes, has a major role to play, right? So what I'll do in the course of this talk is I will try to address the first three steps. So fourth step, as I told you, even though civil engineer's role is greatest in the fourth stage probably is like the lazy person's stage, right? So everything can has already happened. So now you are trying to, you know, bring things back to normalcy. Okay. So in my talk, I'll be focusing on first three steps: mitigation, preparedness, and response, because that's what a wise man will focus on, right? So it's always said that prevention is better than cure, right? So you try to prevent something, and that is always better than what will the steps that you take to recover or cure yourself. Okay, now in this 2-hour talk, what I try to do is some of the things, some major points I had arranged it systematically, but some general points I have mentioned it towards the end, not necessarily with a particular order. Okay, so let us directly jump into the scene. So one of the major news that came recently, maybe actually it's 2 years back or 1.5 years back, is that China built an emergency COVID-19 hospital. Actually, I missed the word hospital. So hospital with 1,000 beds in a matter of 10 days. Now, I should not actually ideally talk in this tone, because the underlying fact is you have COVID-19, as a result of which millions of people are suffering worldwide and there are many deaths worldwide. But one of the things that happened in the backdrop of this in China, where in Wuhan, where the epidemic actually initially broke out, was that they built a hospital for 1,000 beds just in a matter of 10 days. So as a civil engineer, this is a proof of what we are capable in the modern day, right? So 10 days, in such a matter of 10 days, we were able to build this infrastructure. So I have So these are some of the photos that were taken at the construction site during the 10 days. So this is the initial phase. You see all these JCBs, right, digging and doing simultaneous work. And then this is the advanced stage. So this particular event is actually a proof that with technology, we can do a lot of things, right? So this is possible through prefabrication. And this is a very good example of disaster management after disaster has happened. So here the disaster is the epidemic. Okay. So I remember when this happened, we had in our department, we had a talk by an expert from outside. So he was delivering his talk, and towards the end he asked, one hospital was built in China within 10 days. So do you know how they did it? So immediately the student said, he started giving many answers. So that's because as students, you need something which will pump you up, right? So this is something which is fast and furious kind of a thing. So this is something which shows what we can do with the latest technologies in the modern day. Now let us look into what the finer details of some of the things we have to do. So before that, let us look at some major disasters that has hit us in the nearest recorded history. So these are what history tells us. So these are some of the disasters that were recorded in the past 1,000 years. Now, we don't have the kind of, data recording system at that time, what we have now. So we don't know the full details, okay? But some information what we have, it is being combined. Okay, so this shows you some of the major earthquakes, typhoon, volcano, epidemic. So this is actually in 1970. This is the Spanish flu. So this actually killed much more than what the COVID-19, which is still going on. And then you have this flood, famine, cyclone, and earthquake. So these are some of the major disasters that happened in past 1,000 years, what the history tells us. Okay, now we are from this FDPs in Kerala, and recently, in Kerala, we have been discussing floods a lot because we had heavy floods in 2018, 2019, and 2020, right? So even this year, some of the news articles were there, which were published 2 months back, which said there is a chance of flood this time also, but fortunately, we didn't have anything so far, right? Now, all the floods that we had recently, 2018, 2019 and all, what we are said is that these floods, they are large, they are huge floods. We know, many of us, it is said that 1/6 of the population in Kerala were either directly or indirectly affected from this flood. But even then, what we are told is this flood is only second, or 2018 flood is only second compared to the flood that happened in 1924. Okay, so that is mentioned as Great Flood of 99. In Malayalam, we call Tunnutambadile Vellappakam. So the specialty with this flood is it remained as a horror scene for many of the people who lived at the time for many years, even after the flood. Okay, so even the flood of 2018, it is said that it doesn't come close to it, close to 1924 flood. Okay, so anyway, floods also I will discuss in the course of this talk. So now let me discuss a little bit about climate change. So all of you know what climate change is, right? So climate change is such an important phenomenon that it even started becoming the topic of election campaigns. Not in India, actually in US, if I recall a few years back when they had the election, I don't recollect, it was some state election. But the politician was stressing about climate change. Okay, so you can understand the importance of that, right? So if it's a topic that has to become a topic of election campaign, how important that will be. Because see, as civil engineers, we are always concerned with local things, design of a building, or anything which is the structure or whatever things we are dealing with or interested in is mostly a local thing. But what if the entire earth will start to misbehave? So that is what climate change will do, right? So climate change happens on a global scale. So it's not on a local scale. So as civil engineers, we should be vigilant about it, because there is no point in talking about something small if the entire earth is on the verge of an existential crisis. Okay, so very briefly, I'll talk about climate change. You all know what climate change is, but just to set tone for this talk, I'll just give you some points. So large scale shift in weather patterns. So since 1950s, droughts and heat waves appeared simultaneously with increased frequency. Okay, so these are some real phenomena that everybody is experiencing. You don't need to convince somebody about climate change. They already know it. probably they know, even people who are probably not literate or in people who are in villages, you don't need to convince them about climate change. They probably know better than us, right? Because they are seeing all these natural phenomena before their eyes. So some of the things which they didn't experience earlier, now things are becoming, mixed up. Extreme phenomena are happening everywhere. Okay, extreme wet or dry events with monsoon period have increased in some periods. Actually this should be some places. Sorry. Okay, so this is a phenomenon that's happening, and the other direct indication of climate change is the rise in sea level. So we know that climate change is often focused, or it is explained through melting of glacier ice, right? So what happens when glacier ice melts? It will be water which will fill up the ocean, and it will lead to rising sea level. So this is a direct one-to-one consequence. So this is what the average sea level rise in this period. And the most horrifying news that is coming out is, if we go on the same self-destructive path as a human race with all the high emission scenario, sea level could rise by 61 to 110 centimeter over 21st century. Okay, so these are some serious numbers, which is why, when we see all these nations which meet in UN Council and all, climate change is becoming a hot topic. Right? So there is no point in discussing something local when we and the entire Earth and as a human race, we are suffering from this mass scale effect of climate change. Okay, so now let me come to what we can do. Okay, so as I said earlier, towards the beginning of the talk, some of the things, main points are arranged it towards the beginning, and towards the end, I'll talk about some general points which will cover the entire spectrum of civil engineering. Okay, so what can we do? Okay, so first thing is, be a good civil engineer. So that is the basics. So there is no point in talking about advanced things when you don't make sure that the basics are rectified. So what do I mean by that? Let me explain. So first of all, we know that when you talk about, or when you think about a natural disaster, we are going to have massive destruction of infrastructure and buildings. Okay, so every time you have a cyclone or tsunami or even man-made disaster, what you see often in media is a fallen building or a crushed infrastructure, right? So that is what you see. These are the photos that emerge first. Okay, so which means we are the ones, civil engineers are the ones who has constructed and designed it. So we are the one in the forefront of the news. So we all know what is happening in our country, right? Or not, I'm not restricting to our country. Lot of places this is very common. Corrupt practices happen, and what these natural disasters do, or even artificial disasters do, is they expose them. Now, as I've written here, you always don't need a disaster to expose corrupt practices, right? So even without a disaster, a bridge may collapse, a building may collapse, right? So what happens is, when a collapse happens, some investigation goes on, and it is revealed that some substandard practices has directly contributed to that. So this is a big issue that we are facing. So there is no point in talking about what we can do extra if we do not rectify the basics, which is corruption. Okay, it is we all know, right? A person who is working in government level organization, in public service, in such projects, there is a rule that we are being told that there is a rule. Okay, you are engineer at this level, you will get this proportion. You are some engineer at a lower level, you will get this proportion. So it's a rule, not unwritten rule, that you will get this much bribe, right? So if we don't rectify that particular culture of corruption, then there is no point in this entire talk itself, because we are forgetting the basics. Okay, second one is non-compliance with Indian standard codes or international or other country codes. So this is also an issue, right? So we have the Indian standard codes or international codes, NBC, National Building Codes. So these codes are guidelines for us. Now, are these codes perfect? No. These codes are not perfect. That is why they are being revised regularly, because based on the latest research developments, we see that we have to revise certain guidelines and things like that. So codes are not perfect. Okay, and revision will happen. But what we should do as a civil engineer is, at least whatever the code is saying. Sorry, actually one honeybee is playing over me. Actually, in Punjab we have this special honeybee which is yellow in color. Honestly, I have not seen this anywhere except in Punjab. Sorry for the off topic. So everything else fine. My sound is okay.
Yeah. Okay.
Okay, sir.
Yeah, because I need to do this. Even you are also teachers, right? So you also do this in online classes. We don't know whether we are audible or not. If it is offline class, we know, okay, somebody is sleeping, somebody is waiting to get out, somebody is waiting for the time up, and somebody else, maybe 5% or 10% are listening. So this is a common challenge which we have in online system. So that's why once in a while I may ask, am I audible, just to make sure that everything is going on fine. Okay, so the point I'm trying to make is, Indian standard codes or any codes, they are not perfect. But as a civil engineer, what we should do is, whatever is the code in the current form, we should abide by it. Okay, but what we see is, there is non-compliance of Indian standard codes, which also has resulted in lot of disasters. No, means it doesn't lead to the disaster, but some of the practices are exposed after the disaster. So, like major earthquakes like Bhuj or many other earthquakes, what happens is, when the earthquake happens, when the many buildings, they fail in a, honeybee is playing. Sorry, yeah. Okay, sorry about that. So, lot of these earthquakes, when they happen, structural engineers, civil engineers, they start to inspect how the different buildings have failed. So that is like a wake-up call, right? So that exposes some of the poor detailing or building practices. Okay, so many of these codal revisions also, they come up based on these wake-up calls. Okay, but the minimum we have to do is, whatever is the latest code, we should follow it. And next thing is, we have to ensure that the skill set matches the requirement of the job. Now, this is also something we need to address very frequently, because as civil engineers or structural engineers, we have to ensure that the person who is designing or working on a project or given charge over a project is capable of executing it. Now discussions around this, they come up once in a while in media, because see what happens is in Mumbai, you know Mumbai, right? So Mumbai is a special city. So you have the rich, super rich on one side. On the other side, near the airport, you have the extremely poor slums and things like that. And there is a intermediate zone where you have middle class families with whatever, thickly populated. So land cost is high, so it is thickly populated. So once in a while, you see this very often. You might also noted it. Probably every year in the monsoon, you will hear at least one building collapse in Mumbai. So those buildings, they were old. Okay, so probably the design life of it was over, but they were not rehabilitated, nor they were demolished. So they were still occupied and went on. So some of these buildings fail during heavy monsoons in Bombay. Okay, I note it frequently. That's why I'm saying. So when this happens, the importance of a civil engineer or a structural engineer, it comes up. It becomes into discussion. So now what we say is, see, when you pass out as a B.Tech, you are a civil engineer, right? But within the civil engineering sphere, there are certain special roles you might have to play, for which you as a fresher B.Tech cannot take up that role fully. Okay, so that is where we have to make sure that this skill set matches with the requirement of the job or the type of work that is being done. And lastly, in basics, what I want to say is, it is high time that we take the Hippocratic Oath. So this is a oath taken by doctors. We know that when they pass out, it is a oath related to ethics, that we will abide by ethical practices and things like that. Now, in engineering also, maybe we have to bring in something like this. Now, what happens, honestly, we all know, right? When government brings in something new, initially it's like a formality. Like many events were brought into institutes as part of Swachh Bharat mission, Jal Shakti mission, right? So what happens is, when this is brought into the institute, or institutes are given the guidelines, so you implement a oath or you do certain things, it becomes a formality. So initially a coordinator is assigned, so he will have a mindset, okay, let me get this done. So it becomes a mechanical process. So what we have to ensure is, some practices, some oath, either indirect or direct oath, has to be brought in, but it should not be a oath on paper, right? It should be an oath. We should be taking it by heart. By heart, when I say by heart, not to remember, but by heart, so that we can live by these principles, and that will ensure a better infrastructure for the upcoming generations. So these are some general philosophical points I want to discuss in basics. Okay. So let me discuss more technical things. Now, as I said, in a disaster management, there are 4 steps, right? So civil engineer, mostly till now his role is limited to the 4th step. His main part is the post recovery. So what we can summarize the role of his engineering team from the action point of view is the planning, setting up and maintenance of emergency relief camps, provision of and hygienic sanitation facilities are the main responsibilities of a civil engineer associated with disaster management team. So this is in the recovery stage, right? So disaster has hit. Now you have the millions of people who are displaced. So they need to have temporary sheds or facilities, water supply, sanitation, and things like that. So planning, setting up, and maintenance of those, it will come in the fourth stage, and that is part of a civil engineer's. Now let me talk about some mandatory technical rules. Okay, so as I said, fourth stage is the one that we traditionally come to picture, civil engineers. Okay, but we should focus on the first three. As I said, prevention is better than cure, right? So let me discuss with you some mandatory technical roles that we should play as priorities in the initial phases. The first thing is strong foundation, right? So all infrastructure, we know we need to have strong foundation. It starts with foundation, right? So means, see, as a structural engineer, we try to make the structure fully safe, which means every beam, every column, every slab should be, every shear wall, every foundation should be safe in all respects: deflection, shear force, bending moment, everything, right? But what happens is, if there is a local failure, we can rectify it. Suppose a beam cracks or few beam cracks, we can rectify it. But one of the things that can tilt the balance is a weak foundation. So foundation design is very important, and we know that foundation design, good foundation design, starts with a good geotechnical soil testing report. Now what is seen normally in our places is the client tries to save money on the geotechnical report. So I'm in this talk, I'll be talking very frankly based on my experience. So myself, I had experience of working as a structural engineer in USA, in Delhi, in Bombay, and I also worked in Kerala. Okay, so based on this cumulative experience, I have seen what happens at different locations. Okay, when you talk about a big city, small city, medium city, right? So in this talk, I'll be, some of the things I'll be telling from my experience also. Okay, so in foundations, what happens is client tries to save money. So we know that for foundations, there are some rules using which we have to say you have to have this many boreholes to be dug if you have a project of this much area. So when client tries to save money, he'll try to save money on the boreholes. Okay. Sometimes even soil testing is not done. So based on neighbor's plot, the soil strength is ascertained and design is carried forward. Now, 99% of the cases, that is fine. But that is fine when you don't have any disasters. But what happens is when a disaster hits, then some of the cost cutting measures that you have used, that will be exposed. Okay, so when disaster hits, some buildings, it is toppled as a whole, or it tilts as a part, liquefaction happens, many things happen, right? Even in Wayanad, I think probably 8 years back, an entire hill collapsed over a bus stand, KSRTC bus stand, if I remember correctly. So all those things related to soil happens in the case of a disaster. So we need to make sure that foundation is strong, and the geotech aspect plays a major role in that. Now, second thing is flood control, dams, information and advanced design. Now, dams play a major role in disasters, right? So even in 2018 Kerala floods, more bee is laying around me. I don't know where it went. Sorry about that. So in 2018 or 2019 floods that happened in Kerala, what we saw in media was the dams were in focus. So dams were shown, their photos were shown, and they were saying this much is red level, 99 point something. So right now it is orange now. So right now it is yellow, right? So like that, there was this alert mechanism. So dams were shown and people were regularly updated. So the level is rising, rain is still falling down. So what was happening was basically they were trying to determine when they should open the dam or not. Okay. Now, nobody was doubting whether the dam will be safe structurally or not. That was not the question. The question was, will the water level cause a flood downstream? Right. So later on, what we saw was some dams they opened it partially. Some dams they opened fully to a certain extent, and then floods actually increased at some places. So there was a blame game, right? So some politicians they said, you know, this is due to this. KCB started to justify them. Some common people said we should not have opened the dam this fast. So basically, it was a cat and mouse game, right? Now, whatever happened, means the comments of certain people, we can ignore, we should ignore because it may be part of politics. But what we cannot ignore is the fact that the water level in the dam played a major role when the floods happened. Okay, so that's when we have to realize that it is not just the hydraulic design of the dam that is important, and not just the structural design of the dam, but mechanism has to be developed in the event of emergencies that will ensure that if you are expecting a heavy rainfall, you need to arrive at a suitable mechanism by which you should be able to release some water. Okay, so that is the important point with dams, because we see that very often in the case of disasters. Now, the other role that is important is the role of city planners and project managers. Now, we talked about IS codes. So, IS codes and international codes, they have a role to play. On a more local level, each city, each town, each state, they have their own corporation rules, panchayat rules, city planners, right? So they also need to give robust guidelines, because overall IS codes will only cover the all country scenario, which may not be applicable for certain specific locations. For example, Wayanad or Idukki, right? So such places where you have a hilly terrain and things like that, you need to have certain sets of rules which are specialized for such locations. So that is where city planners and project managers can play a major role. They should be swift enough to incorporate guidelines that will ensure that disasters can be minimized, and even if the disaster strikes, the casualties and loss in property is minimized. And next is rescue operations and safety escape routes. So this is also very important, because when a disaster like an earthquake happens, we know that people are crushed inside huge boulders, right? So some of them may be even alive. We have heard about miraculous stories where people have remained alive for many days. But nevertheless, you know, the rescue operations is something very important, right? So when floods happen in Kerala, NDRF team had to set in. So central team, they came, so they had whatever helicopters and all those setup, and they were doing the rescue operation. So that is on a larger level. So on a smaller level, in a building, we need to have safety escape routes. So that will be taken care. So if the building is made as per the building rules properly, safety escape routes will be there. Okay, so that should be there. Plus, in addition to that, there should be drills. There should be mock drills where there is a false alarm and people can practice the safety escape route. So I remember myself when I was working in Delhi. It was I think in year 2010-11. So it was a 9-story building. Okay, so they had planned. So if that was a 9-story office building, there were different office, different companies in the building. So one day they planned and they kept a false alarm. So they said, okay, this is the time. So in that time, you try to escape, or the exit escape stairs were open and people were asked to come out and some instructions were given. Okay, so that is needed because safety routes are there, right? But since it happens only in emergencies, not everybody may think of it in the case of emergency. So you need to have such mock drills and separate training sessions where you practice to the inhabitants. So now we see that often in aeroplanes, right? So first thing we see in aeroplane, once you sit down, the air hostess will come all this hand exercise and that what are the things you should do in the case of an emergency, right? So such emergency practices, actually in aeroplane, those who are regular flyers, you might be by heart, right? You are used to see it so often that it is by hearted in your mind. But in the case of buildings, we have to do it at least once in a while. Now, this is not as relevant in small projects, but at least in metro cities, I think they are doing it, but I'm just stating the importance of that once again. And then, you have the issue of hazardous and toxic waste, which should be properly, whenever it is created, it should be properly disposed of to prevent harmful effects on environment. And then air pollution, drainage, and radiation pollution. So these two are basic things. So you all know about it. So I won't waste much time on it. Okay, so these are some of the technical things we can take care of. Okay, so now let me discuss about certain specific things which has been done in the past and which we should focus on in the upcoming days. So am I audible? Everything fine?
Yeah, yes.
Okay.
Fine.
Now, okay, thank you. So when you talk about disaster management or climate change, what will always help us is greenery, right? Vegetation. So trees or plants, that is what is helping us in everything. Okay, even against global warming. And so the thing is, how much trees we have, that much we are better off. Right? So there have been some latest attempts that has been made in bringing more greenery towards buildings. Because in the last 50 years, we know that construction technology has improved, mass production has improved. And as a result of that, we are building taller and larger dams, buildings, bridges, and each country takes pride in making larger and bigger buildings, right? So as a result of that, drastically our environment is getting destroyed. So one of the things that has been attempted very recently is bringing landscape to buildings. So this is an example of a building in Tokyo, Japan. It's an office building. So what they've done is this office building grows sufficient greenery or vegetation that will feed the inhabitants of the office. Now, I'm not saying that, see, it can be very well that in the construction of the building, the loss in or the harm on ecosystem might be more than what they're trying to do now. Okay. But what I'm saying, the point I'm trying to make is, these are all steps. These are all directions we have to think in future as well. Okay, so these are more photos of the building in its interior. So you have these plants that are growing. So this is that, and this is also a picture from the office building. Now you have to imagine this. So normally when you have an office building like this of 8 or 9 stories in a urban location, you can imagine the cost of the space, right? So clients are always interested in increasing the carpet area. So that's why columns we try to give a higher grade so that we can increase the usable area. Because in our urban areas, the rate is for square feet of space. So in the same building, you see this area, all this area, actually it's a trimmed photo. The full photo is larger than this. These areas, they are using it for the vegetation, crops. So which means the client is actually losing this area. He could have given it for rent, right? Normally we don't do this in a typical scenario, but this is all part of this novel initiative to create vegetation in buildings. So many new buildings, they are trying to implement these things. Now some of the motivation to implement these things may be for a touristic value or to increase the iconic value of the building, but it is fine because as long as it is serving our purpose, we are happy, right? So we'll talk about these initiatives more later on when I talk about LEED, okay, LEED rating and things like that. But this is a good initiative. We have to push towards more greenery. So that is also one of the things city planners also do. So city planners, when they build big cities, so we know that bigger cities, the land value is more, right? So in such big cities also, one of the important points of planning is we will reserve large areas of land for parks. So that is actually a sign, that is now becoming a sign of a good, well-planned city. So even in New York City, which is the largest city in the world, arguably, you have a central park. It's not a central park, it's a huge park which has acres in the center of the city. Actually, I have been there. So these are all some initiatives that have been taken, right? So we are trying to, one of the things that happened is due to this mass construction and planning, vegetation has been cut down, but slowly now the trend is by people understanding the importance of disaster management and climate change, we are trying to bring back greenery, parks and all those spaces to allow for some damage recovery, okay, what we have done to the environment. Okay, so this is one such initiative. Now let me talk about how we can tackle climate change by material choice. So as we know, in civil engineering, construction is what is one of the main things that we do, right? Now, depending upon the type of material we use, it can play a significant role in the direction we are pushing the earth towards. Okay, so that's where we will discuss the choice of material. Okay, so we all know what are the construction materials that are there. So one of the materials that will help us in sustainability is reclaimed wood. Now, wood construction, okay, before I talk about reclaimed wood, let me talk about wood construction itself. Now, in the current scenario, current Indian scenario, wood construction is not that much popular. We are going to steel, concrete, and materials like that. But if you look at our grandparents' homes and all, or such old structures, we will see that wood has been used to a great extent. So in Indian scenario, wood as a whole, it is losing popularity, but that's not only in the Indian scenario. In the developed countries, wood is still used as much as it was used earlier. Okay. So here I am going to talk about reclaimed wood. So what is reclaimed wood? So reclaimed wood or reclaimed lumber is a processed wood retrieved from its original application for purposes of subsequent use. So what we do is, you have a wood which you have originally used for some other structure or some other purpose. So what we do is, that particular purpose, once it is over, instead of throwing away the wood, we will reform it, refurbish it, and use it for some other civil engineering structure. Okay, so that is what comes under reclaimed wood. Okay, so it's a sustainable building material. Now, wood as a whole, we know that it's a sustainable building material, right? So we are harming the environment as less as possible by using wood. But one of the challenges that comes with the usage of wood is, you are cutting down a tree, right? Even though the usage of wood helps, is eco-friendly, you are cutting down a tree which is indirectly harming environment. But when you use reclaimed wood, you are already using the wood that has been in use. You are not going to cut a new tree for that. You are just reprocessing, refurbishing it and using it again. So it is a sustainable option. Okay, and as I said, it will ensure that no living trees are destroyed, and minimal energy consumption in the process. So wood as a whole, it's a sustainable material, but in the process of making it a construction material, you need to use some energy, which will again contribute to global warming, climate change, and things like that. But when you are using reclaimed wood, some of the energy consumption is minimized, which will help. Okay, so wood is one of the best materials to reduce climate change. So when wood paneling and flooring are chosen for homes and offices, large amount of carbon can be stored, reducing emissions. So these are all things we know about wood, right? So also research has shown that wood produced the least amount of carbon compared to other common materials that are used in construction. Okay, and this point we already discussed. So when you are using reclaimed wood, it's a win-win situation. First of all, the usage of wood itself helps to reduce certain things. Second thing is, you are not cutting down a new wood. Okay, and so it eliminates the production of new wood. Okay, so this is reclaimed wood. So this is one such initiative that was carried out, not in India, but abroad, where they use reclaimed wood to build this structure. Now, reclaimed wood, can you use it for high-rise buildings? So those issues I'll discuss it later on. Okay, so scalability is a big thing that we have to talk about in reclaimed wood and other products. So I'll come to that later. Now let us talk about recycled non-wood materials. So about wood we talked, right? In reclaimed wood, you are reusing it. Now what about non-wood materials? So recycling is something which is very much preferred in civil structures, simply because it is sustainable, it improves sustainability in multiple ways. Now, one of the growing trends in research is biomimicry. So you know what is biomimicry, right? So people or engineers are trying to mimic what is happening in nature. For example, Japan's first bullet train was designed based on the kingfisher's beak. So the Japanese engineer, he noted that, actually the problem that was happening was when the train comes out of a tunnel, it was creating huge noise. So they were studying what can be done to minimize that noise. So one of the engineers in the team who were designing this train, he was a bird watcher. So he was watching a kingfisher. So what it kingfisher does is, when it wants to catch a fish in a water body, it goes down very smoothly with very minimal noise and takes the fish and come out. So if it makes noise while splashing, then fish can escape, right? So that particular beak, shape of the beak, that was allowing the king to catch the fish with minimal noise, that was the source of inspiration for the engineer to design the shape of the Japanese bullet train. So with that shape, when it comes out of the tunnel, the noise developed was minimum. So the point I'm trying to make is, biomimicry is something which is gaining ground. So engineers are doing things by learning from what is happening in nature. Even one naturally air conditioned building was built in Africa, I think, I don't remember the country, in which they have studied the natural air conditioning of built by a termite. Okay, so one of the things that they are now focusing in biomimicry is, in nature, nothing is a waste. Anything that you put organic, so even a dead body of some insect, it will be eaten by some other insects, and it will be further eaten by some other. Some of them will decompose. So, and that will be a fertilizer for a plant. So in that plant, you have some fruits that will grow. So fruits, you eat it, remaining, if it goes into the ground. So it's a natural recycling process, right? So what the engineers who are trying to do biomimicry, now they are trying to focus is, how can we minimize waste? So just like nature minimizes natural waste, how can we minimize artificial waste? Okay, so in that context, this topic is also I'm discussing. So here we'll discuss some of the recycled non-wood materials that is being used in construction. So over the last several years, some serious progress has been made in the area of recycled material creation. Many traditional building materials such as steel and tile can be found in recycled form. While these materials initially had a negative impact due to their creation and production, reusing them is a great way of keeping them out of landfill and reducing the future impact. So just like I talked about reclaimed wood, in reclaimed wood, what happens is, your reuse of the wood is preventing a cutting of a new tree. So here also, when you are reusing something from a structure to a different structure in a different form, two things are happening. First of all, you are keeping these materials away from landfill. So that will prevent pollution and further issues. Second thing is, you are saving on money or the harmful effect or negative impact that is associated with creation of a new material. So it's a win-win situation. Okay, so now many architects are getting creative with various types of recycled materials. I'll show you some real projects also. So plastic buckets, bottles, bed springs, ice cream containers, they are all now being used for innovative projects for making some special building facades. Okay, so this will prevent reduce carbon emissions and things like that. So now let us look into some projects. So this is a project that was done in Turkey. So it's a cafe. It's a cafe, but the exterior of the cafe, it was built using metal plates, recycled metal plates. Okay, so this is a good example of sustainability. Okay, so you are preventing a production of a new material, and along with that, the associated harmful impacts of that particular production. And this is another example where a building project was developed in, so it's actually a library project that was developed in Indonesia. So what they did is, they were looking for a facade with the following qualities. So they wanted to be affordable, that is one, right? Then they wanted it to be from a locally available material. At the same time, they wanted it to provide shade. They wanted it also to enable air and natural light. So when they thought about all these options, they come up with such an option. So this is actually ice cream tub. Okay, so this is an ice cream tub. They are used here. So multiple ice cream tubs. Excuse me for a second. Hello, madam. Oh. Oh. Madam, actually, I am giving a talk in FTP. Can I call you, come to you after 11 o'clock? Okay, extremely sorry about that. Actually, call came because if I don't answer it properly, next calls may came, which will create more disturbance. So sorry about that. So this is one such projects where they are used. So these are ice cream tubs. Okay. So these tubs, what they done is they kept some of the tubs with solid exterior like this, and remaining tubs they kept it like this with a gap. So it's a soft both. You have solid face as well as the cut face. So what this does is, this is affordable. There is locally available material. It provides shade. It's everything. It solves the purpose of sustainability, and it's a win-win situation. Okay, so this is one such projects. Now let us look at certain other projects where they used old materials. So this is a project in Mumbai. Okay, where what they done is, so this is a project that was built to house many generations of the same family. So there was an extended family, and they wanted to make a house that will have each one of them, right? So what they did is they did a facade. So facade means you know what it is, right? So it's the exterior. So they did a facade in which they made it using old doors and windows and some other antique materials they used. So this is also another way, right? So they have, first of all, they have used old material, which means they are preventing its disposal before it degrades. Second is, it prevents the manufacturing or lessens the manufacturing of a new material that might have led to some carbon emissions and impact on environment. So these are some initiatives which are being taken, okay, because everybody understands the urgency, right, of this sustainability. So these are more photos from the same project. Okay, so in the elevation, it looks all windows and doors. Some of them are permanently closed, right? And some of them, it can be opened to function like a regular window. Okay, so this is the other way. So this is yet another example of what they did using old materials. So this is a, yes, go ahead. Anybody? Any question? So this is a building in UK. It's a university research facility. So they have made this building using used carpet tiles, and that is what is used to clad the walls. So that is the exterior of the walls. And this is used along with for insulation. It is also some floppy disk, toothbrushes and things like that also used. So this is yet another example. Now, again, as I told, what I told during reclaimed wood, it is easy to do these things for small structures, but can you do it for big structures? So that is where we have to discuss the issue of scalability. Okay, those things we will come to. Yeah. So the next, probably this is the last sustainable construction material that we'll discuss. So the material known as rammed earth. So this rammed earth, it was something which was used in the past. So in between, we were lost and we started using new materials. Now the focus, since the focus is again back on sustainability and green building, we are now moving towards rammed earth. So what is rammed earth? So rammed earth is simply a construction technique where you use soil compacted in layers in a certain specific manner. So it's the earth itself, the actual earth itself, that is acting as a building material. So it used to be used in the past, but as I said, nowadays, since again now focus is back on preventing climate change and sustainability, we are now again going back to this. Engineers are going back to rammed earth, and now there is a resurgence in this particular approach of building. So no doubt it is a low carbon option because you don't need the sophistications that we normally do require for complicated building materials. And even stabilized rammed earth, which uses small amounts of cement or lime, is better alternative for using instead of materials like cement for an entire project. So rammed earth, it uses some amount of cement or lime, but that is still better than regular buildings where you use cement for the entire project. So this is one such building that have been constructed using rammed earth. I don't recall the location, actually I put it in the reference. Okay, now so rammed earth is also something we can think about, moving ahead, talking about curbing climate change and sustainability. Okay, everything fine till now? Audio is fine?
Yes, sir.
Okay, so now from this point onwards, let me discuss or let me summarize the main things we can do moving forward. So some of these things I will discuss. I have not discussed it earlier yet, but as we move along, we will discuss them as solid concrete points or steps that we have to take going forward. So one thing is you have the leadership in energy and environmental design. So you all know about LEED, right? So LEED is a body which has even started a rating system. So depending upon the green practices your project is following, your building or project will be given a certain amount of green rating. So platinum, gold, silver. So these are different rating systems. For example, the lighting system that you are using, the plumbing system that you are using, or certain the amount of fly ash that you are using in concrete. So depending upon certain choices that you are making, it will save it will lead to saving of destruction in environment. Means the greener practices you make, the better environmental friendly or eco-friendly your building will be. Okay, so there is a point system. There are different criteria, and depending upon how much points your project will finally get, this agency will give you a rating. So your building is gold rated or silver rated or platinum rated. Right? So this system is already there. Okay. So in metro cities in developed countries, they have implemented it earlier itself. So in metro cities of India, it is catching up. Now even in smaller towns, it is catching up. Okay. So they are doing a good job. So what we can say at the current scenario is they can probably do a better job. Since this is a rating agency which can control a lot of things, in their point systems itself, they can bring about strict guidelines which will ensure more sustainable construction practices. Because see, what you have to understand is you have to understand the psychology of the client. Even if you are the client or I am the client, what we are trying to do, if we are going to do a civil engineering project, our goal is we have to make it a sustainable project, or we have to make it a profitable project, right? So in this lead rating, it is something which is used as a marketing technique. Because you have a project which is being built and you will say, okay, this building is gold rated or silver rated, right? So from a client's point of view, it is good for the marketing, right? So some of these points, since a client will be striving for these points to get their building rated, incorporating some of the strict guidelines in lead rating. I think somebody is okay. Yeah, it happens, right? It happens in online classes, so we are used to it. No problem. So some of the things that we can do, it will have an impact on sustainability. So I remember, see, every builder, every client has their own marketing strategy. So at a point of time, some clients were advocating on carpet area. So they say our building is more than 90% carpet area or something like that. So like that, every builder, every client will have a marketing strategy. So the latest marketing strategy is with regards to its lead rating. And I was surprised when I saw probably around 8 or 9 years back, that a new project that was coming out in my own hometown in Calicut, in the newspaper itself, they were advertising in boldface. So this particular project is green rated. Okay. So to get that green rating, client will indirectly adopt sustainable practices, and such lead has a major role to play in improving sustainability that will help reduce disaster management and climate change, or improve disaster management and reduce climate change. Second thing is disaster management and climate change should come as part of curriculum. Now, one of the things that we are seeing, so people like me who has completed their education, undergraduation 10 or 15 years back, what we see is AICT is regularly interfering in curriculum changes. So earlier, when we studied, there were a lot of core courses, more civil engineering courses, but nowadays some general courses, humanities, ethics, and like that, some general courses are being deliberately brought into the curriculum. Right? So as a result of that, some of the core courses we have to move it out. Okay, so this is the thing. As I emphasized earlier, civil engineers, we deal with small things, but when I say small things, we deal with an individual project, right? But there is no point in talking about the individual project if the entire earth is on a damage mode, right, due to climate change and things like that. So that's where, you know, we have to catch the young minds early itself. So in the UG curriculum itself, we have to bring in subjects, or if not full subjects, at least part subjects where we talk, mandatory subjects where we talk about the importance of disaster management and climate change in the curriculum. Okay, because disaster management and climate change happens on a large scale. Now, other thing also we are seeing, I talked about syllabus. So the new thing that we are seeing is, following the guidelines of the syllabus, some of the competitive exams are also changing. Earlier, competitive exams used to have only technical questions. So nowadays they have aptitude and some of them even general affairs and things like that. So one bold move that can be taken is, some of these competitive exams like IES, GATE, assistant engineer and things like that, it can have mandatory questions on climate change, for instance. So that will motivate people to study and it will improve the awareness. So it's all about awareness, right? So once you have to improve the awareness, so once everybody knows importance of something, it is easy to push things on a global level. Okay, so the next big thing is government level regulations through international bodies. Now, they are doing things, I'm not saying they are not yet doing. So there are many international bodies like UN, and separately there are bodies which have only some nations like BRICS. Okay, all these international bodies, they can push agendas that can help regulate climate change. They are already doing it. So just reiterating the same point on its importance, because see, as an isolated or as an individual civil engineering, there is a limitation on what you can do, right? But if suppose rules are brought down on a country level or an international level, then things can change drastically. For example, government can introduce tax cuts for using sustainable materials, right? So that will encourage builders to go for certain materials and not for certain other materials, right? So these are some government level things that can happen. Now, what happens is, some of the government level decisions or policies that will be met with resistance. So people will oppose it, right? But things become smooth when there is an international body. So if an international body that is consisting of many nations, if they decide to bring in universal laws, then independent resistance from a particular country won't be there, because it is applicable or it is coming from an international body. Okay, so there is something we can do. IS codes, it should have explicit guidelines. So right now, we know as civil engineers, we are heavily dependent on IS codes. It gives us do's and don'ts. You can do this, you can't do this, right? So now it is time, since climate change is such a hot topic. Sorry, excuse me. It is high time that we have some IS codes, some guidelines which are explicit. And see, IS codes, it gives you the final outcome, what it should be, right? So maybe what we can do is, in addition to talking about what it should be, we should also bring in some terminologies like climate change or disaster management to help the scene. Because see, IS code, any IS code, it is based on latest research findings, right? So every IS code, they have a committee, expert panel, faculties from IITs, some NITs, from government organizations. So they are the policy makers. So they have the power, right? So they decide on something, they can implement it through the code. And a civil engineer or structural engineer is liable to follow it. So some guidelines can be brought in where you not only talk about the what is required as an output, but the cause also, or the reason also can be discussed. So that is one major change we can work on. And we can promote specific materials. So as I showed you some figures, we have to promote sustainable materials. When I talk about sustainable materials, it's not just about the sustainable materials which are made from scratch, but also things like reuse of materials and refurbishment of old materials to use it again. So this is also where government can play a major role, right? So as I told you, government can say, okay, we will give you tax cuts if you are a company who are working on these materials which improve sustainability. So that will be like a promotion of such technologies, such materials, right? So that's why, even if you see on a overall level, nowadays the major companies like Reliance, Adani and all, they are going green. They are investing in renewable energy. So why is that? Because government rules are giving them subsidies and laws that can help them or make it a profitable business, right? So like that, there should be a proportion of companies which involved in sustainable materials. Actually, I should have written promotion of sustainable companies involved in sustainable materials. Okay, so that is one thing. Because materials, as we discussed, it is one of the major things that will help us in the topic that is at hand. Prefabrication. So prefabrication is something which is catching up. So in disasters, we said, so once a disaster strikes, suddenly you have to build all those makeshift accommodations, sanitation and things like that. So doing that in a short time can help you only if we had developed a habit of prefabrication. Just like the hospital of China that we discussed, which were built during COVID-19, you had the parts already assembled from factory, you just had to place it. That's how we could make it, they could make it in 10 days. Otherwise, if you are going to do the traditional construction inside, it will take a lot of months, right? So prefabrication is something which we have to think about from the point of view of a disaster. Okay, material choice, we discussed about this. So it's not just about recycling or reuse, it's also about the primary material that you are going to choose, because all materials, they have their production process, they have their background of how you get the raw materials. So depending upon all those things, the amount of eco-friendliness you get with a particular material, it can vary. So this is, we emphasize this. Reuse of material also we emphasize. I'll skip this. Vegetation in buildings. We talked about the case of Japanese buildings. Now, in such scenarios, even code can play some role, because in IS codes currently you have IS 8754 loads, right? IS 875 part 1 is for dead load, part 2 is for live load, and so on. Now, IS codes can incorporate guidelines when you have vegetation load. So actually I was guiding an MTech student for project on a building analysis, and I was surprised to find that there was landscape related codal guidelines in US codes. Okay, so that is like an indirect promotion. You are indirectly as a code, you are promoting the use of vegetation, right? So we have to also do it in IS codes. So it is an indirect motivation to use such things. So I think some messages, I heard a voice that message is being given, but I hope I can continue. Right? I can continue. It's fine.
Yes,
That's for the participants.
Yeah. So maybe I'll take another 5-6 minutes, and then I'll open the floor for any questions. Okay. Yeah. So the next thing I would like to emphasize is BIM. So BIM is something, is the latest trend that is growing, building information modeling, right? So just in the last 10 years, many countries, I think some microphone is on. In last 10 years, many countries or many government organizations, they have decided that the government projects will be modeled using BIM. So what is BIM? Building information modeling, or BIM, is a complete package, right? So no doubt BIM is greatly improving in its usage, and it is expected that in the next 10 years, there will be a huge demand for BIM engineers. So when you say engineers, automatically India is we have a lot of engineers, right? So all the international projects that now will be modeled in BIM, it is currently coming, and it is anticipated that a lot of those projects will be worked on by Indian engineers. Even just recently, one of my colleagues in my current institute, he was saying that one of the companies, they asked him whether you have BIM in your curriculum, because the company is a reputed company. They were trying to recruit engineers who have experience with BIM. Okay, nevertheless, the point I'm trying to make is BIM is very important. Okay, so for implementation of BIM, you have many softwares like Revit. So BIM is a complete package, right? So it will help structural engineer, MEP engineer, architect, client, everything. So throughout the life of the structure, from construction to the end of the life of the building, what all happens in a building, it is, you can model it using BIM. Now, just recently, I've been interested in BIM for disaster management. So I was trying, it was in my mind, it just didn't materialize. I was trying to work on a research topic where you can use BIM for disaster management. So BIM is already, the concept of BIM is so complete, because you are talking about a project from its before construction planning up till its design life, maybe 70 years, 80 years. So you are talking about BIM which can model all the effects, including light, heating, everything from start to end. So there is a increased research where BIM can be used for disaster management. Now, when you talk about BIM for disaster management, you are talking about one particular project, right? But this particular BIM for disaster management concept, it should be explored on a city level or a town level or on a larger level that will help in better disaster management. So this is definitely a direction we should go for. And next is, of course, GIS. So we all know the importance of GIS, right? So when a disaster strikes, whatever type of disaster, a satellite imagery or the aerial view is what helps us to work on a global level, on a larger scale. So GIS or global information system is something which we civil engineers should invest our time and effort more for disaster management and curbing climate change. So even in climate change, certain phenomenon that result in climate change, it happens on a large scale, right? So it's not on a small scale. So to track what is going on a larger scale, you need to use GIS very effectively. Because so this is also something, a direction which we should go for. Now design more accepting of a renewable energy setup. So this is also something which we can do as civil or structural engineers, because see, one of the things that nobody has doubt over is the fact that global warming or disasters can be reduced, switch to renewable source of. So renewable source of energy, there are different types. Okay, so one of the things we can do as civil engineers is we will try to make our project directly adaptable to. One common example is rooftops, right? So rooftops of any building, water tank here and there. If it's commercial or office building, we might have huge mechanical handling unit or AC. Mix all the background associated with the MEP of the building, you will have it in the roof. Same roof, you might have a lot of empty space. So those empty spaces, we are a consist renewable energy sources like rooftop, solar top, so coming up in the entire renewable energy, and right, so your help environment, and that will help in natural disasters on a contribution on a one project may be on a small level only, but you are at global level will help, and climate change also will be reduced because renewable source of energy. Okay, and next big challenge is upscaling sustainable solutions. So I have told you, we discussed some sustainable building options, right? So all those projects I showed you, they were on a small scale. So the biggest challenge is how can you repeat that on a large scale? So if it's a 3-story, 4-story, 5-story building, how can you do that on a large scale? So that is also something we have to consciously work on, thus sustainable solutions to a large scale. And so I'm almost done. Let's just 2 more points. So other thing is, see, disaster management team. So there are now, especially when in the aftermath of Kerala floods and things like that, the planning, disaster readiness planning bodies have been formed. They were there initially, but they are now given more power and they are being empowered, right? So if you really think about a lot of factors are from civil engineering side only. So it's like, you are fitting a jigsaw puzzle of civil engineers. You have to have an environmental engineer, you have to have a structural engineer, transportation engineer, right? So the thing is, individually, we know our discipline. So if you are transportation, you know your discipline, structural engineer, we know our discipline. So the point we have to now focus is how we can fit all those together so that we can work as a team that can help prediction and recovery from disasters. And finally, we should have more conferences and FTPs on this particular theme. And I'm very grateful that we have this particular. So when I was first contacted for a talk on this FTP, I was surprised that the theme was this, because normally when you see an FTP being conducted from a civil engineering department, you expect a more technical topic. So this particular theme of the FTP is good, and we need more such FTPs and conferences, because the simple way of curbing disasters or reducing disasters and climate change is by educating the masses or creating an awareness among people. Okay, so this is what the points that I have. These are some of the main references, and this is it. So if you have any questions, you can. The floor is open for questions.
Thank you, sir. Now we are opening the floor for Q&A session. If any participant have any queries, they can post in the chat box. Sir, meanwhile, I have a question. So you talked about reamed earth, right? So what type of soil we can use in reamed earth?
Actually, that's a good question. So all types of soil are not feasible. So suppose if it's a clay soil or easily liquefiable soil, we can't use it. But what suits the type of soil that suits rammed earth concept are more soils which are like lateritic, or soils which are not tricky. When I say tricky, those are soils which change their behavior when it is subjected to moisture. For example, what we see is in Wayanad, in places like Wayanad, what they say is certain places the soil is tricky. So when water comes into it, its properties change drastically. So basically, rammed earth concept is good, and it is more suitable for soils like lateritic, where it is more predictable, and it is lateritic. Actually, lateritic stones and all we are already using in construction, right? So it is more suitable for such soils, which you can use it predictably.
Okay, sir. One more question. Sir told about BIM in disaster management. So is there any particular software that do this disaster simulation or something?
Actually, that is a very good question. See, actually, I'll tell you, before I joined MIT Jalandhar, I was working in a college in Andhra Pradesh, Malappuram Institute of Technology. So I was fascinated about BIM at that time itself, but using UG project. So I was having a B.Tech group under me who is doing project. So I was trying to give them this topic. So BIM using disaster management using BIM. Okay, so I think probably they were a little lazy and they couldn't work that much. So currently, see, the plan I have, so based on what I read, what I can say is the softwares that implement BIM, it is so complete. So when you talk about BIM, so if you are, as I told you, there are many softwares for implementing BIM. So one of the softwares is Revit. So you have a Revit model for a project. So the same project model, you can view it from an architectural point of view, structural point of view, MEP point of view, right? So when a disaster strikes, the idea I have in mind is software will be same. It will be the same Revit model, but the software can show you more things. For example, a fire breaks out at some point.
Sir, your audio is muted.
Yeah.
That's right. Yeah. So suppose a fire breaks out at some point on the building. Okay, so the Revit model should show you what are the different escape routes for different persons, how much time it will take from the fully loaded capacity of the class, from first person to last person, right? So like this, a live updated Revit model. So when you talk about BIM itself, as I told you, it starts from starting of the construction to the end of the life, right? So when you have a lively Revit model, BIM model that is being updated time to time, it will help in the rescue team to guide the people inhabiting the building to escape. Okay, so it is a way of rescue operation, effective way of rescue operation. So that BIM model is for one project. So now let us upscale it. So you have a big town. Okay, so you have this, suppose a town of Calicut or Thrissur. Actually, we still don't have much tall buildings, but you take the case of Bangalore. Okay, so you have multiple big projects that are all together. So what you can do is you need to have a synchronized, coordinated BIM model that will simultaneously inform the rescue team of what is going on individually, and that will help in coordinated effort. So this is actually only in this is very recent. BIM is there, it started, but the disaster management using BIM is only a recent topic. So some of the ideas I have is in this particular direction.
Okay, sir. Thank you. I think we have no more questions. I would like to invite Mrs. Vidya Kanagarajan to deliver the vote of thanks. Participants, kindly fill the feedback form. The link will be shared in the chat box.
Okay, thank you, Fayaz. I would like to thank Dr. M. Abdul Akbar, who shared with us the session on civil engineers' role in disaster management and curbing climate change. I like the way how Sir explained the various methods that we can contribute to climate change as a civil engineer. Sir also suggested the inclusion of topics of climate change in the curriculum, which is enlightening. Thank you, sir, for being with us and sharing your valuable ideas. Also, I wanted to express our paramount gratitude to Dr. M. Abdul Akbar for accepting our invitation as a resource person from the beginning of our FDP proposal and is with us throughout. Thank you, sir.
Thank you very much. I am very delighted to be this talk.
Yes, sir.
Thank you, ma'am. That's the end of today's first session. Hope all the participants have filled the feedback form. Thank you.
Okay, thank you, sir.
Thank you.
Hi, sir.
Yeah, good morning.
Yeah, good morning, sir.
Good morning.
Once again, good morning and welcome back to the program. Now it's time to move to the second session. I request Babu as Assistant Professor, Civil Engineering Department, to introduce resource person to the participants. So please.
Yeah, thank you, Harida. Am I audible?
Yes, sir.
Yeah, thank you. So very good morning to one and all. I am extremely happy to introduce today's keynote speaker for the second session, Dr. Srivalsa Kolathayar. Sir is currently working as Assistant Professor in the Department of Civil Engineering, NIT Surathkal. He completed his MTech from IIT Kanpur and PhD from Indian Institute of Science and served as international research staff at UPC Barcelona Tech, Spain. Dr. Srivalsa sir has authored 5 books that are now subscribed by worldwide university libraries and published over 80 research articles. He is an associate editor of 2 international journals and acted as a reviewer for many international journals. He is currently the Secretary, Indian Chapter of International Association for Coastal Reservoir Research, and Executive Committee member of Indian Society of Earthquake Technology. In 2017, the New Indian Express honored Dr. Srivalsa sir with South India's Most Inspiring Young Teachers Award. He received IEI Young Engineers Award by the Institution of Engineers India in recognition of his contribution in the field of civil engineering. Recently, Dr. Srivalsa sir was featured by the American Society of Civil Engineers in their Geostrata magazine. With this brief introduction, I welcome you, sir, for the keynote session on the topic Civil Engineering for Disaster Risk Reduction. Thank you very much.
Thank you. Thank you very much. So
Thank you,
at
sir.
the outset, I thank the organizers for inviting me to deliver this talk, and very warm good morning to all of you. And thank you for the introduction. So let me share my screen. Is my screen visible to you?
Yes, sir.
Fine. Okay, let me make it full screen. It is full screen, right? Is it visible in a presentation mode or?
It is visible, but not in full screen.
Okay, maybe I have to share the entire screen. I shared as a window. Yeah, what about now?
Yes, sir. It is visible as full screen.
Okay, fine. But I think if I share in this mode, some of the video sound may not be audible. Anyway, fine. Then that is no problem. So
Okay,
can
sir.
I start?
Yes, sir.
Okay, thank you. So please pardon me. Actually, I am just recovering from cold. So I had a severe cold and cough. So my sound may have some problems with the modulation. So please bear with me.
Okay, sir. Thank you.
And I will be talking on, though my topic was civil engineering for disaster risk reduction. So I'll be focusing a little bit more on the geotechnical aspects of civil engineering. And I will be highlighting some of the extracts or contents from these 5 books, which are shown here. One is on earthquake preparedness, published by Springer, and the other one on earthquake hazard assessment by Taylor and Francis. CRC Press, and another one on seismic sonation by Springer. Fine. And one book on water resources and another book on soil reinforcement. So I will be extracting some important contents from these books authored by myself along with other experts and professors and presenting to you in next 1 hour or so. So you are very well aware about the natural hazards as well as man-made hazards. Natural hazards like earthquake, floods, landslides, tsunami, and there are several man-made hazards like war or even road accidents, etc. If there is any issue with my screen sharing or audio, please let me know. Fine. So there is actually a common terminology that is being used, that is natural disaster. Actually, it's a wrong practice to use the term natural disaster because there is no such thing as natural disaster. Well, so all of you know what this picture is. This is the Leaning Tower of Pisa, one of the wonders of the world. So why it is leaning? It is because of differential settlement. Actually, it was a engineering blunder. The foundation was not designed properly, but the blunder became a monument. Because it tilted, it became a monument. If it was perfectly vertical, it does not become a tourist attraction. Now, if same phenomenon of differential settlement happens to our house, what would happen? It does not become a tourist attraction anymore. Rather, it is a disaster, right? Because our building will crack and it will lose its utility and function. So what is a hazard and what is a disaster? There is no such thing as natural disaster. Natural hazards like floods, earthquake, landslide, etc. become disaster as a result of human and societal vulnerability and exposure. And it can be addressed by proper planning and preparation. This is said by United Nations Chengdu Declaration of Action in 2011. So they are saying that there is no such thing as natural disaster. Natural hazards become disaster because of vulnerability and exposure. Now, how do you define risk? There are 4 elements of risk: hazard, exposure, vulnerability, and location. So UN says risk represents the presence of vulnerable elements in areas exposed to hazards. We can say you are at risk when all these things come together. So if you take your Arogya Setu app, you can do self-assessment and find out the level of risk you are under, whether you are at high risk or moderate risk or low risk. That also considers all these 4 elements. One is hazard, that is COVID, whether COVID-19 infected people are there. Then location, it will trace the location within 1 kilometer radius, how many patients are there, how many infected people are there. Then exposure, how exposed you are. If you are wearing a PPE kit, you are less exposed. If you are wearing a mask, you are less exposed. And vulnerability, if you are old or if your immune system is weak, you are more vulnerable. So higher these 4 elements, higher the risk. So higher the exposure, higher the risk. Higher the vulnerability, higher the risk. So how you can reduce the risk? So if you want to reduce your risk due to COVID-19, either avoid such location or be less exposed, wear mask, or boost your immune system, be less vulnerable. So any risk can be reduced if you can reduce these 4 elements. Like if you are at a location where there is an earthquake probability, so how you can reduce risk? What is you can relocate your structure, planned structure to another location. That is why nuclear power plants are planned in seismically low to moderate vulnerable regions, not in highly active regions. So that is change your location or reduce exposure. Like for your building also, you can give a screen like vibration isolation layer, then reduce the exposure of the building from shaking, or reduce the vulnerability, use good quality materials and reduce the vulnerability. So you can reduce the earthquake risk. So when infrastructure development happens, you see a lot of buildings come up slowly. And if these buildings or structures are not designed to withstand the earthquake forces, this is what happens. Because there is a saying, earthquakes don't kill people, but buildings do. It is due to collapse of structures. Most of the casualties happen due to earthquake. And it can be prevented. How? With proper engineering. So this is an example. This is a picture from Kobe Line, Japan, where they have retaining wall on the left, and you can see some of the houses on the right side. In 95, there was a major earthquake. After the earthquake, you see all the fragile building houses got collapsed, but retaining wall is intact. Why? Because it was engineered wall. It was reinforced with a geogrid. The geogrid reinforcement, that is the engineering innovation here. It is not even concrete, it is soil only, but it is reinforced with the geogrid. So it was able to withstand the earthquake forces. So through proper engineering, you can reduce the risk of infrastructures. This is the major location with high seismic activity. If you come to India, in the Himalayan region and the Northeast, they are very highly vulnerable to earthquakes. Some of the pictures of damages from Indian earthquakes. Shillong earthquake, Kangra, Bihar, Nepal, and 2005 Kashmir earthquake. It took around 80,000 lives were lost. Then damages due to site effects and liquefaction. So earthquakes don't kill people, but buildings do. And many injuries and death happen due to collapse of structures. So the solution lies in buildings, not in earthquake as such. Earthquake is not the culprit, but buildings are the culprit. So if you can take care of the design of structures, you can reduce the risk. That is why it is important to have engineering preparedness measures. And for the first step is evaluation of hazard. You must understand what is the level of hazard in any region. Now, if you see how humans respond to earthquakes, after an earthquake, in first 1 minute or so, there is fear and panic. People know they don't know what to do. Then 1 minute to 1 week, rescue operations go on. Then next 1 month, there will be blame game. Then next 1 year, people will call for higher standards. That is why after Bhuj earthquake, immediate next year, our earthquake zonation map was revised. Then next 10 years, people will forget. After that, till next earthquake, completely everything is forgotten. Once another earthquake happens, all these stages are repeated. So this cycle has to be broken. Preparedness should come well before the disaster. Then only we can reduce the risk. Coming to earthquakes in India, it is because of the collision of Indo-Australian plate with the Eurasian plate, Himalayas was formed, and because of that, that region is highly active seismically. And 15% of great earthquakes happened in India in 20th century. So these are the list of some of the earthquakes happened in India. We can see there are earthquakes that happened in South India also. They are called intraplate earthquakes. So this is the zonation map as per IS standard. This was first developed in 62, then revised in 66, 70, 84, and finally in the year 2002. Still, it is not a scientifically developed map. This is based on past earthquakes. So many people have highlighted that there is a need to do a scientific hazard assessment. So I will present you a case study of India, how a scientific hazard assessment has been done. The first step is earthquake data collection from literature, for historical data, and from several agencies for instrumental data. I will just skip fast forward this. And this is the earthquake data showing for the period 250 BC to 2010 AD. Actually, I have collected this myself from different sources. You can see high concentration of earthquake in Andaman Nicobar, Northeast, Himalayas. Then they were converted into a unified moment magnitude scale. We have developed our own relations. This was published in seismological research letters. Then aftershocks and foreshocks were removed. That is called the declustering process. So this is the final declustered earthquake catalog. Only independent earthquake events are shown here. And this is the map showing the seismic sources like lineaments, faults, their discontinuities actually in the crust, earth crust. And India is actually very diverse in seismotectonics also. We have active tectonic region in the Himalayas, stable region in the southern India, subduction zone in Northeast. So different ground motion prediction equations has to be used. So ground motion prediction equation will give you the ground motion parameter, that is acceleration, as a function of distance and magnitude. So there are several relations available. And we have developed our own relations using the earthquake data from PESMOS, that is a IIT Roorkee project funded by Ministry of Earth Sciences. So we did a multilinear regression analysis and developed our own ground motion prediction equation. So this was published in 2019 and 20. Then we evaluated the seismic hazard deterministically as well as probabilistically. So I will not go into the details. So deterministic seismic hazard assessment involves first a selection of or identification of sources, then calculating the shortest source to site distance, then evaluating the ground motion parameter using ground motion prediction equation. So this is the spatial variation of PGA value in and around India. Then we also did a seismicity analysis, because even though earthquake event appears to be random, there is a trend. So if you plot number of earthquakes with a magnitude, there is a trend actually. So based on that, we did a seismicity analysis and also did a probabilistic seismic hazard assessment using 18 different models and methods. So this is the final map showing the peak ground acceleration from the probabilistic approach. So you can see Northeast, Kashmir and Gujarat. So they are highly vulnerable to earthquakes. So if you want to see your location, like say Kerala. Kerala also, it is actually very low to moderate seismically active only. So not very highly vulnerable. But this analysis will give you, as engineers, we are interested in the quantity, in the acceleration value for design of the structure. So this will give us the design parameters, or we usually follow a pseudostatic approach or IS code method. So you will get the peak ground acceleration from this map. Then site will amplify. That is why when earthquake happened in Bhuj, Ahmedabad, a lot of destruction. Ahmedabad is far away. It is because of site effects. They will amplify. Local soils will amplify the vibration. So we have for entire country, so we have done a analysis using correlation between slope and site amplification, because steep slopes, no, they will have a hard strata. You see the steep mountains, no, they're very hard rock they will have. So based on that slope value, we arrive at the shear wave velocity. So you can see the Himalayas, no, green, very high shear wave velocity or very high slope. And in the Western Ghats, you can see hilly regions are having hard strata. Then we brought the hazard to the ground level, considering appropriate amplification factors. So we can see the PGA at the bedrock level amplified, say 1.5 times or so, when it was brought to the ground level. And this is another case study we did for a power plant at Chittagong, Bangladesh. There actually we had the soil data. So we did a site response analysis. So there is a deep soil software available for that. So we did equivalent ground response analysis in deep soil and found the amplification factor and did the study. Also recently we have published a paper on population exposure to seismic hazard for Delhi, population and land use exposure, because it is the land use type. If you have a lot of buildings and earthquake happens, the loss will be high. If you are in Greenland where there are no people or no buildings, even if an earthquake happens, there is no risk actually. So population and land use also important factors. And we also developed an earthquake readiness index tool to assess the preparedness level of the individual and community. And these kinds of camps and workshops are very important in boosting the awareness. So if an earthquake happens, say, now, what will be your reaction? Actually, first step is be calm, then drop, hold on. Cover your head under the table or coat, save your head, because most of the casualty happens due to falling of non-structural elements. Because earthquake lasts only for few seconds, the vibration, there is no time for you to get out of the building, especially when you are in the first floor or so. So it is better to avoid staircase and lift also. They also may become non-functional. So it is first cover your head. When vibration stop, get out of the building and stay in open place, because there can be aftershocks. Because when earthquake happens, this is how the buildings behave. Like the inertial force, no, when bus suddenly starts, top portion of our body goes in the backward direction. Similar thing happens to house also. So if structure is built with the less stiff material, it can withstand high earthquake forces. Similarly, if you have a slope, under natural condition, it may be stable. When there is an earthquake, so it will contribute to the driving force. So even in the angle of repose, that will not be safe. So you need to take care of that also and reinforce and stabilize the slopes. So ductility, higher ductile material if you use, there is less chance of collapse and performs better. Especially that is why geogrid reinforcement, no, that is very effective. Like I have shown this initially. So when we talk about earthquake hazard, assessment of earthquake hazard is very important, and local soil conditions can amplify the seismic waves, so site amplification needs to be considered. And these PGA values that estimated from a deterministic or probabilistic seismic hazard assessment will help us in assessing the safety of structures and also to evaluate liquefaction potential. And spectral acceleration values corresponding to different periods, that is response spectra, will help us to understand the behavior of structures, and community preparedness is the need of the hour. So this is the book page which talks about earthquake preparedness, which we have published a couple of years ago. Fine, that is about earthquake. Now I want to move on to water security. So please give me a 2 minutes break. So I will just take a 2 minutes break and continue. Please hold on. Thank you. Yeah, sorry. Hope I am audible.
Yes, sir. Yes.
Yeah, fine. Yeah, thank you. So I want to highlight a little bit on engineering schemes for water security as civil engineers. No, so we can do a lot in sustainable water solutions. So India is a country of rivers. We have several major rivers: Ganga, Yamuna, Godavari, and Brahmaputra. And our annual rainfall in India, I have last 100 years data, and it has not varied much. But what has become is the distribution has become very erratic. Means we are receiving in just a few days, we are receiving several months rain. So then what happens? Then there is a flood. There is no time for water to percolate into the ground. So there is a flood, and also we have our surface paved. There is no space also for water to percolate, and there is no time also. So during rains we have flood. Then during summers we have drought. So actually, because of this kind of infrastructural development and deforestation and soil erosion, siltation, so water bodies also lose their capacity to store water, and there is flood in the rivers. because silting happens due to soil erosion. So there is no space to store water, flooding happens. If you see the example of Bengaluru, so in 1960, there were about more than 150 lakes. And now it reduced to just 64. The Majestic bus stand, no, it was a lake, Dharmabadi Lake. So that is the situation. So storage capacity is reduced. So that is why we are suffering from water scarcity. Otherwise, actually, if you see the annual rainfall map of the world, India is shown in green color. We receive enough, plenty of water. That is 4,000 kilometer cube of water we receive from rain. But still, 54% of India faces high to extremely high water stress. So we say India is not running out of water, but water is running out of India because we are not able to store the rainwater. We have more than 6,000 large dams in the country, and the capacity of these dams, all total capacity is less than 400 BCM. Even 10% of the precipitation water we are not able to store. So I want to show you some of the traditional water harvesting structures in India. And they are all very relevant to civil engineers, geotechnical engineers especially. This is spawned from my own place, actually, my own home in Kasaragod. So you can see in rainy season and summer, even in summer also, extreme summer also, we are able to irrigate the farmlands, and the water table has not gone even by an inch down in last 30-40 years because we have a lot of several water storage structures. So they are called kolams in Kerala. And tankas in Rajasthan, we store drinking water. Khadins or dhoras, there's like an earthen bund is created to store water. Jalaras, Rajasthan. Bawdis. This is SBI logo, has taken from this Kankaria Lake actually in Gujarat. Ahar pines of Bihar, when there is flood, they divert the water through long channels, so that will recharge the groundwater, and finally it is stored in Ahar. So this is a flood protection structure actually, Ahar pines. And they also recharge groundwater. Inundation channels of Bengal. Bandaras, Maharashtra. Cheru in Andhra Pradesh. Tanks, Kares or Kalyanis in Karnataka. Adjacent to every temple, there is a big water pond, That is in South India, that tradition is there. And it was a visionary approach because we are able to store a lot of water during rains. Because storage is most important for storing fresh water. Then sinks in Ladakh region, storing water that is coming from the snow. Then surangas in northern Kerala and southern part of Karnataka, they are horizontal wells. They are drilled through laterites, and they are very high quality water we get from these surangas. They are equivalent to canals in Arabian countries. Then if you look at hydraulic engineering in India, Great Bath of Mohenjo-daro, Dholavira in Gujarat, Sudarshan Lake, all long back to BC. Then Kalani Dam in Trichy, that is built by Chola King Karigal in 1st century AD. There's a 4th oldest dam in the world, and it is still in use. So anyway, that is about traditional or ancient structures. So there is a need to preserve some of those structures like surangas or ponds, etc. So because that is the only sustainable way we have now. Or some of the modern techniques like having contour bounds, pits and shaft, boulder checks, recharge well, water pool, afforestation, etc. So this is a case study from Jharkhand where I was involved personally. some of the recharge wells. And this is another case study from Uttarakashi. So they have Ganga at the downstream, but in the top of the hill also they have water source, but they are in the mid. So how to fetch the water? So actually they have perennial source at the top. So we have made some recommendations to revive that. Another very important structure, groundwater dams or subsurface dikes or underground dams, because we know about dams, surface dams. So underground dams, water is stored below the earth, and you can have your trees, buildings on the soil. So they are stored in sand with a clay, impermeable clay membrane, or even using geomembranes, or even using concrete dikes. So they actually arrest the subsurface flow and keep the water. So which are the options that we have to ensure good quality drinking water? We can have more reservoirs, but that is now opted out because globally dam construction is being stopped because they cause a lot of environmental hazards or interlinking of rivers. There is also, it has several environmental implications. Groundwater, one of the best source, we need to recharge the groundwater. Or desalination plants, they are very costly. Wastewater use, we use it for gardening, etc., but not for drinking purpose. But in Singapore, etc., they use, or coastal reservoirs. So dam construction, no, US, Canada, they are decommissioning their dams. Globally, dam construction is coming down because there is no space also. This is another view from Kerala. During summer, there is a pori or sandbar. Naturally, they are formed by blocking the river and sea so that saltwater intrusion is prevented. So you can see Porikara view. And similarly, Marina Barrage people, they have constructed an artificial barrage and they got a UN Environmental Award also. Marina Bay, which was having salt water, they converted completely into fresh water. Very beautifully designed. So I want to show a video. I am not sure whether audio will be clear, but anyway, subtitles are there. So you may please watch.
What most precious resource on earth. Only 2.5% of world's water source fresh water. And out of that, 1% is easily accessible, finding traffic close. All this is about 1,000. Large amount of fresh water is flowing, mixing with salt water. At one side, large quantity of fresh water flow into the sea. At the other side, people struggle to meet their water demands. Erratic distribution of rainfall event cannot be stored by land based. The issues associated with the land acquisition, displacement of water, to construct large dams or dams. The coastal reserve concept emerges as best alternative freshwater storage. The reservoir construct at the mouth of the sea can tap the fresh water during floods and allow the river water. Coastal reservoirs can meet the water demands of nearby cities. Coastal islands. Civilizations around the world developed coastal reservoir has the potential to transform collected and polluted coastal region sustainable clean freshwater culture, self-sufficiency, solar, and save water and save nature. International Association Reservoir Research.
Thank you. That was a short video on the concept of coastal reservoirs. Actually, I am acting as the secretary of India chapter of the International Association for Coastal Reservoir Research. Why I have shown? Because one of the oldest coastal reservoir in the world is actually in Kerala. It's in Tannirmukkam Bund. Some of you may be aware. Actually, I have recently published a paper also on this Tannirmukkam Bund. It is not called as coastal reservoir in Kerala because it was a bund actually locally made, but actually it is a coastal reservoir. So we have done an appraisal of that. So you know Vembanad Lake, no? There is saltwater intrusion. So they have constructed, I think in 1970s, a barrage was constructed so that fresh water from the Pamba and Meenachal River is stored in Vembanad Lake and it is used for cultivation. And when there is rainfall and excess water, the barrage gates are open and allowed to go into the sea. There are several problems also, issues also associated with, because it was not done scientifically. So this is the aerial view, but recently the Swaminathan Commission report, no, they made several recommendations to revive the system. Now new gates construction is also almost completed. This is another proposal for the Ashtamudi Lake. Ashtamudi means it is like 8 arms, no? Now there are only very few arms. Others have been actually got filled. But at least if one arm can be, I have shown in a dark blue color, Ashtamudi Lake, that is the portion where we have highest depth. So if we can convert that into a fresh water, because Ashtamudi Lake, you know, it's a brackish water lake, whereas Shastamkota Lake is a freshwater lake, but it is very small. So if one part of the Ashtamudi Lake, you know, by constructing just a 200 meter dike, there will be good connectivity through that dike. And the water from Kallada River, so around 125 TMC of water comes from Kallada River every year. So a little bit can be diverted to this arm and fresh water can be stored here. Around 12 TMC can be stored and it will meet the water needs of entire Kollam, Ernakulam and Thiruvananthapuram also. There is a concept actually. We have even submitted a proposal to Kerala government also, but we have not received any positive response yet. But we have published, we have done some academic research work and published also. But that is a possibility because that region is where there is a high, we have analyzed the bathymetry data. So there is a high depth. So large amount of water can be stored. So this is the condition of several ponds in our state actually. They are all going to collapse or getting filled. So there is a need to protect these structures. And to new constructions also it happens. And we know Kerala faced landslide in 2019 in Kavadapara and 2020 also Pettimudi. So it is actually last 2 years, past 2 years, we faced a very extreme landslide disasters. Around 80 to 90 houses were buried under this. So you can see a small portion with a vegetation cover. Some 7-8 houses were saved. So this reinforcement by tree roots, that is very well known since ancient times, especially the vetiveres, the roots go very deep, even beyond the soil surface. So some natural schemes can be designed to reinforce the soil. So we have done some studies using natural fibers. This was published in Journal of Materials in Civil Engineering ASCE and ASTM Journal. So natural fibers have very good capacity to strengthen the soil. Microstructural characterization also we have done. So you can see the fiber soil interface. So there comes importance of geosynthetics also. There are actually artificial materials, geosynthetics and different types are geogrades, geomembranes, geotextiles, etc. And they have applications in land engineering, coastal protection, rockfall protection, canal lining, revetment, flood control, slope retention, etc. So these type of geogrid reinforced soil walls are very common, especially for almost all the expressways and highways. This is followed these days. So we have done some studies or using Arakka leaf sheath, no? Arakka leaf sheath. So I have patented also. We made in the form of geogrid and performed the test. They have higher tensile strength than the commercially available geogrid, and performance is also very good, as good as the commercial geogrids. Because commercial, they are very costly. Arakka, this is actually available for no cost actually. But they are brittle and the durability is an issue which needs to be addressed by proper treatment. So this is another book we recently published last year on geocells, that is cellular confinement. So what is that? I will tell you that. And it has a lot of applications in embankment, paved road, footing foundation, earth retaining wall, slope control, erosion control, etc. So this is how it looks like. They provide a lateral all-round confinement to the soil. This is how it is installed in the field, and they allow the growth of vegetation also. So we have patented Arakka leaf sheath geocells also, and it was published also recently, last year, in 2019. So we have performed the test, and its performance is as good as commercially available geocell and geogrid. Because they are commercial HDP geocells are very costly. So this is how it performed, the mechanism through lateral support reaction, vertical stress distribution, and membrane effect. This is how the pressure, the failure surface looks like in normal case. If the soil is reinforced with the geocell, there is lateral confinement and failure is confined within the cells. Membrane effect, lateral support reaction, etc. and vertical stress distribution. And the bearing capacity increased 4 to 5 times increase there. We also did several experiments with Arakka cell, Kayar geocell, Jute geocell, Cell, etc. And recently published in AC, International Journal of Geomechanics. So geocell retaining walls is also possible. We did another model study using geocell retaining wall to control the slope erosion under load, and by replicating rainfall conditions, we performed the test. So we found that natural geocells made of Kayar or Arakka, they are performing better than the commercial geocells under wet condition, under rainy condition. This was published in Geotechnical and Geological Engineering by Springer. This is a case study for the Mumbai-Pune Expressway, where we were involved as a consultant. This is another case study from Mangalore NH66. There were 4 to 5 collapse in a 1 kilometer stretch actually. So you can see the collapse. So they approached us and I was the consultant in charge. So we have designed a system like this using soil nailing and geocells. So this is very low cost because people usually go for RCC retaining wall. They create a high carbon footprints, not eco-friendly, and very, very costly also. Whereas these geocell, they are eco-friendly and they life up to 100 years. It will last. There is no problem of deterioration, and also provides high strength also and very low cost. And it allows vegetation. In the facings, you can even plant vegetation like vetiver, etc. So soil reinforcement using alternative materials offering lateral confinement to the soil like geocells is very cost effective, and it can reduce the risk and disaster. Natural materials like Kayar, bamboo, jute, etc. Can be good alternative to increase the bearing capacity of weak soils, and especially in soil retention using geocell retaining walls, etc. So ecosystem-based disaster risk reduction is the future for sustainable development. So these are some of the books we recently published, in addition to what I have shown earlier, some more books like ground improvement techniques, etc. So I will stop my presentation here. Actually, I am sorry because I am not feeling well, so my lecture may not be as effective as it should be. So please pardon me. So because I have committed and this comes actually, I just got vaccinated last week, maybe because of that. So it is untimely because we cannot avoid also. So sorry for that. If you have any questions, I will be happy to take.
Thank you, sir. Now it's time for question answer. Participants can post their questions in chat box.
Yeah, I can send some materials if needed. If there is any question, yeah, please feel free to type in the chat box.
So you have one question.
Yeah. No, I am not able to see any question.
No, sir. No, sir. So sorry.
Yeah, it was a comment actually.
Comment.
Yeah, there is a question from Harita Srinivasan. Can you give some details about the warning systems of earthquakes in India? See, earthquakes cannot be predicted actually. Scientifically, we don't have any system or tool to predict earthquakes. Prediction means we cannot say when, we cannot say the exact date when it will happen. But warning is possible, very short duration warning, because first the P waves arrive. P waves travel at about 6 km per second. Followed by that, S waves come. S wave travel about 3 km per second speed. So after P waves are arrived at our seismograph, after few seconds or maximum 1 minute, within that S waves will come. It is with the arrival of S waves destruction happens. So when the P waves are arrived, you can give a warning, but only few seconds before that, and that is not going to help, or that is not in evacuating the people. Only thing is that you can shut down the power lines so that associated hazards like fire, etc. can be avoided. But evacuating people from buildings, it is not possible. But tsunami warning is possible, because when you receive the earthquake waves on your seismograph, because tsunami happens because of earthquakes in the ocean. When the water waves come, water waves come slowly. They may take 3-4 hours. It depends on the distance and intensity of the earthquake. But once you receive the earthquake wave, and if there is a probability of tsunami, you can warn the people at least 2 to 3 hours before, and you have time to evacuate. So tsunami warning is effective, but earthquake warning is not effective because only few seconds before you can warn. But earthquake estimation, hazard estimation can be done like, for Himalayan region, there is a seismic gap, means strain energy is accumulated. You can say in next 50 years, anytime a major earthquake may happen. But when that will happen, we cannot say. It may happen today, it may happen tomorrow, it may happen after 10 years. So we don't know when it will happen. Exact date we cannot say, but we can prepare ourselves by practicing what to do before, during, and after an earthquake, and by retrofitting our buildings. So there is another question. Many methods other than barrage construction to prevent saltwater intrusion. For preventing saltwater intrusion, see, I don't know where you want to apply this. If it is to prevent, because in rivers, up to several kilometers actually saltwater get, especially when there is high tide, So for that, there is no option that we can do. But to prevent saltwater intrusion into your wells, etc., there are some techniques like providing impermeable membranes, etc., that may work. So, but it also depends. For example, I am now in a coastal city, Mangalore. Here actually there was a well actually for my one of my colleagues. There they used to get very fresh water. But once they inserted that concrete ring for the support, after that they are always getting salt water. So something happened actually, some water passage, it is very near to the sea, but they were getting fresh water. So something opened up. So actually I am not a hydrogeologist, so I cannot comment much on that. But using geotechnical schemes like dike or barrage, up to an extent you can prevent, or using a geomembrane also. Different types, Babu is, sir is asking, what are the different ways by which landslides can be prevented? See, landslide also, recently also you might have seen some Himachal Pradesh, very huge landslide, over 100-meter highway stretch was gone. So one is actually we have to respect nature, because when there is disturbance, we are increasing the chance of landslides. But where there is no human intervention in forest, so landslides happen. So some such global failures, it is very difficult to prevent. But local failures, definitely we can prevent by proper retention systems, reinforcement, etc. And the global failure also, the maximum what we can do is encourage vegetation, especially like vetivares. Recently, the Tata estate, they have around 10,000 acres of land. Some 20 landslides happened in different locations. So I was a consultant. So we have, because it is very difficult to construct some systems for the entire 10,000 acres. So we recommended them where there is high probability, some erosion control mat, and to plant vetivares. So vetiver, they will hold on the soil. So that is one system. And if you are constructing any building or infrastructure, you have to do a site-specific study, understand if there is surcharge load coming. You have to give proper. There are different mechanisms like soil laying can be done, or reinforcement can be done. So reinforcement using geogrades, or railing, or even using biotechnical stabilization like vegetation cover, etc., or erosion control mat, etc. So there are different techniques, or retaining wall also can be provided. So there are different methods. So it has to be done site specifically, depending on the need of the site project. Yeah, well water contamination. Yeah, fine. So for that, I am not an expert, but we can provide some geomembranes if possible. Like even our septic tank also, there are some guidelines. It must be away from well this much many meters. So, and especially if your well is in the coastal areas, actually there are situations where there are wells very near to the sea, and people are getting fresh water. But I am not a hydrologist or hydrogeologist, so I am not very good in that subject, so I cannot comment much. But there are techniques while constructing itself. If there is a seawater intrusion that is coming, saltwater intrusion coming, with some impermeable membranes or geomembranes, so you can prevent to an extent. But detailed regarding well, actually, I am not an expert to comment. As the groundwater is flowing out from Suranga, is it recommendable when compared with open wells? Yeah, from Surangas, if you get into the Suranga, there will be water source actually. They are identifying that water source, and that is coming through the Suranga, and that is collected in a pond actually. That is how, even my area, in my uncle's house also, they didn't have electricity around 20 years ago. When they didn't even have electricity, they used to get water from Suranga on top, and they used to irrigate entire farmlands by gravity. They had pipe connections. Electricity was not there. So to their house also, all time pipe connection is there, and there is no even outside. They don't even close the tap because it is a perennial water source, and entire farm is irrigated from that water. So Suranga, actually it is stored in a pond, and it was taken via pipelines, so to the house or farmlands. So it is a perennial source, so water keeps on coming. So Suranga, wherever it is possible only in laterites, because laterite is stable, so that you can drill horizontally also. So open wells, actually in many of the regions, Suranga cannot be employed, so we go for open wells. And there are some regions where open wells you don't get water, but in Surangas, because there can be some water sources actually. So that is how it is detected and constructed. Thank you. So,
Thank you, sir. I would like to invite Ms. Humaida Al-Hadi to deliver a vote of thanks.
Good morning, sir.
So one more.
yeah, it's a natural hazard actually. When you say cloudburst is also a natural hazard.
Okay, thank you. So, I wanted to express my paramount gratitude to you, sir, for delivering a session on this topic, that is civil engineering for disaster risk reduction. It was a really informative session, sir. Due to your illness, you said that you have rushed through the slides, but I personally felt that what you taught us already conveyed to us through your slides. Your slides are very nice, and it is full of pictures that your thought is already conveyed to us better. Thanks for that. Next, you explain the things in a eco-friendly manner. That is how risk reduction can be done in an eco-friendly manner. That is also conveyed, sir. Very, it's so. I, from the bottom of our heart, I really thankful to you for attending our session and give us such a nice talk. Thank you, sir.
Thank you very much. Thank you.
Participants,
Okay, thank
kindly
you,
fill
sir.
up feedback form. Link of same is shared in chat box.
Yes, sir. Really, thank you. It was really informative.
Thank you very much. Thank you, sir. Can I leave?
Yeah. Oh, yes, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
That's the end of today's second session. Hope all the participants have filled the feedback form. Join back at 2 p.m. today's final session. Thank you all.
Good afternoon, ma'am.
Good afternoon. Is my voice audible to you?
Yes, sir. Yes, ma'am. It's audible.
Thank you.
Good afternoon, all. Welcome back to the program. Let's move on to today's final session. I request Professor Irshad Abdulaziz, Assistant Professor, to introduce the resource person.
Irshad, sir, unmute.
Okay.
Okay.
Am I audible?
Yes, sir.
Okay. Very good afternoon to all of you. On behalf of Civil Engineering Department, I am very pleased to introduce today's speaker, Dr. K.G. Tara. She did her doctorate in geology and post-graduation in disaster management from Delhi. She is a former member of SDMA and head of Disaster Management Center, Government of Kerala. She has attended international trainings in disaster management from ADPC Bangkok, World Bank, Germany, etc. She has 13 years of teaching experience in the engineering college and 3 years as scientist in geology in Kerala State Remote Sensing Center and 16 years as head of Disaster Management Center. She has won the Young Scientist Award in 1993. She has attended around 500 TV programs and 487 radio programs. We are very fortunate to have such a talented person for our FTP. I welcome you, ma'am, and over to you, ma'am. Thank you.
Thank you, Irshad. Thank you so much for that very brief, nice introduction about me. Are you a faculty?
Yes, ma'am, faculty in MESCE itself.
Okay. So, can we start now?
Yes, ma'am.
Do we have to wait for anyone? More people to join?
Okay, then we'll wait for a few minutes too.
Are we expecting more people to join, or is that all? 30 students, 30 participants? Can we start?
No, then we can wait for a few minutes, ma'am.
No, it's okay with me. I mean, I leave it to you to decide. It's okay with me to wait.
Okay, then 2 to 3 minutes we'll wait.
How many more are expected to join?
Sessions, there'll be about 40 to 45.
Okay. Chitra has joined now. Okay. Only Irshad's number is visible now, visible to me. All others are just, all the alphabets in the English language, like FDP civil.
Oh, yes, ma'am. That we coordinate is created.
Okay. MES. What is MESC?
MES College of Engineering.
Okay. I should have guessed it. Okay.
Ma'am, I'm one of the coordinator, Vidya.
Vidya?
Vidya from MES Civil.
And I can see another lady also there.
I'm Humaida Alhadi.
Humaida.
Humaida. H. Humaida.
Okay. Nice to meet you all.
Thank you.
Are you also a coordinator?
Yes, ma'am.
Humaida?
Yes. Yeah.
How many coordinators do we have?
Just two.
Okay.
Yeah.
So in case somebody is incapacitated, a stopgap arrangement is also there. Okay.
Yeah.
How are the sessions going?
Okay.
Going good. Are you all faculty members or any students are also expected?
Yeah, some of our MTech students are also joining here.
Shall we start with this? I think it is, the number is reasonable now, 34.
Okay, ma'am. You may start.
I hope my screen is visible to you.
Yes, ma'am. Yes, it is visible in full screen. Yeah.
Okay. Entire screen. Okay. So what we are going to do today is to share a few ideas about disaster risk management, how planning makes planning becomes an important factor in risk reduction, and how can we what kind of awareness is needed to build up resilient communities or societies, be it the stakeholders or the communities who are actually experiencing the disaster. So recently, we all know that United Nations International Panel for Climate Change, IPCC, they have come out with the 6th assessment report. It is called as AR Assessment Report 6. AR6 is, it stands for the 6th assessment report, brought out by IPCC, International Panel for Intergovernmental Panel for Climate Change. And it was published recently in 2021. It deals with, or it narrates what are the impacts which we can expect in climate change, and what are the future risks, and what can we do to adapt or to mitigate. These are the 3 or 4 areas on which this report is focusing on. And we for people who are still doubtful about climate change and the havoc it can bring about, several reports are coming from various parts of the world. Globally, it is being reported that climate is undergoing an irreversible change, and some regions, some countries are experiencing very, very hot climate, and the temperature is increasing day by day. And some other countries which used to be cold are experiencing extreme cold events. This is a village in Russia where one girl's photo is shown here. Her eyelashes are also seen frozen with the cold. So it is reported that the temperature has gone down to -62 degrees Celsius, which it is very difficult for any living being to survive in those extreme climates. And a very interesting story came from Sahara Desert in Saudi Arabia. It's the largest desert in Asia, we all know. And they just receive 50 millimeter rain per annum altogether. And in contrast, we are receiving 3,000 millimeter rain per annum. So in a year. So 50 millimeter rain, a desert area which is which is getting just 50 millimeter rain, we can naturally expect huge sand dunes covering the whole area. But I think in last year they reported snowfall. So it was quite unexpected and unbelievable for the Saudi Arabians to experience a snowfall, that too in the midst of a hot desert climate. So this is a poor camel standing with all the snowflakes. And many people seem to be really concerned about what is happening, except the former president of USA. He said that it is quite fabulous that that climate change is happening, because people in Saudi Arabia get to see the snow, and people in Russia's their eyelashes get frozen. This is such a fabulous idea, and we can expect these kinds of remarks from world leaders like him. He's no longer in place, but he's a person, he's the one and only president, I think, who said that, who suggested, why don't we drink sanitizer to drive away the coronavirus. And people came up with, the social media came up with a lot of trolls showing the former president drinking Dettol to get rid of the coronavirus. What does this IPCC report hold for India? We all know that India is an agricultural country, and it is ranked as one amongst the 5 largest producers of over 80% of agricultural producers. We are basically an agricultural country, and we know that our agriculture is totally dependent upon the climate and the weather, mainly the rain and the sunlight, and it is the main source of livelihood for about more than 80% of population. Agriculture also provides about employment opportunities to about 52% of the labor. So it is very, very, very important that we take into consideration the climate change and its impact in India, especially in various sectors, like how is it going to affect our agriculture sector, food security, and how is it going to affect our construction sector, housing, livelihood, so on and so forth. And it is estimated that this climate change impacts will result in a reduction of 25% in the crop yield. That means that we are heading towards a serious food security issue. I'm just narrating the possible reasons or impacts which we all know by and large, but just as a reminder of to all of us as to what to expect in the next few years and what is the best option that we can go ahead with, especially being engineers and mainly the civil engineers, what best options are available to us. And limiting the temperature to 1.5 degrees Celsius is very, very important. At least to 1.5 degrees Celsius, average temperature increase should be controlled at 1.5 degrees Celsius because it will, if it crosses this 1.5 degrees centigrade Celsius, then we will have to face much more serious impacts, and it will result in very severe food and water insecurity. So basically, as engineers, we need to look at housing sector because agriculture is not in our domain. So housing sector and what we can do to ensure water security and also the stability of the structures. And some points might already have been discussed by various speakers in the previous sessions. But before we go ahead into the detailed discussions, it is very, very, very important. Let me once again remind that it is very, very globally it is accepted that it is very, very important to control the heating up to 1.5 degrees Celsius average temperature. And by and large, India has already experienced about 0.74 degrees Celsius average increase in the temperature. So we just have to, go a few more degrees to reach this 1.5 degree Celsius target. So before it crosses this 1.5 degrees Celsius target. And there is a sort of urgency in this, in controlling the temperature, because, if it is not met within 12 to 30 years, then things might go out of control. And we only have actually 12 years. That is what most of the experts agree upon. And every region in the world is seeing irreversible changes. So before it is too late, we need to act. And last 20 years, climate-related incidents have increased from 59 to 820. So it is very, very important that we focus on climate-related disasters and the impacts it can have on the building and the structures and on the livelihood and also the availability of water. And most of the fatalities are happening because of the flood and the drought. So importance of water is being stressed more and more. And we are spending a lot of money globally. From 1998 to 2017, we had to spend $79.5 billion in managing climate-related disasters, and there is a 151% increase in such incidents. And on an average, 200 million people are getting affected per annum. And India is ranked third in maximum natural disasters. This is based on the record data from 2000 to 2019. 80,000 lives were lost, 100 crores were affected. China still ranks first, followed by USA in the number of incidents, and India retains, or it has been elevated to the third position. India and Bangladesh, both countries are very, very vulnerable to natural disasters. So talking about the heat aspect, this is the heat map of hazard map of India. Heat waves has resulted in 13% of deaths in the last 20 years. So as the temperature goes up, availability of water also comes down, and it becomes quite unbearable for the people to live inside concrete buildings. In 2015, May to June, just in between these two, within these 2 months, almost 3,000 people, they met with death because of rise in temperature, and most of the people were, field workers or rickshaw pullers and below the poverty line people. So. And India, we all know that the number of incidents of the cyclones is also increasing. 8% of the land is already vulnerable to cyclones. In talking about the water scenario, the groundwater level is dipping every year. Each year it is dipping more and more. And especially the northeastern northwestern states, Punjab, Haryana, all these states are experiencing this shortage, severe crisis in water, and it has an impact on the farmers who are already on strike for ensuring their livelihood. And we have to always remember that farmers constitute 60% of Indian population. So the main responsibility of all of us, especially the engineers, is to save as much water while constructing a building, and to reuse the natural resources to the extent possible, because we need to cater to the interests of the farmers as well, because they are already in deep trouble. And we all know that just 0.3% is available to us, and 1.5 billion cubic meter cube of water is being used by industries alone. That shows the importance of water, and this is a world map of water stressed area, and high stress, extremely high stress, that is more than 80% stress is experienced by all these red colored countries. Wherever these red zones you see on the map, these are all highly stressed countries. And 70% of the land is already vulnerable to droughts. So what are the options available to us? This is a water management system that is being followed by the Japanese. It is called as GCANS project. Writing is not very visible. Alphabet G, D-CANS, C-A-N-S, D-CANS project. You can just Google and look for more details. It's a 6.5 kilometer, it contains 6.5 kilometer long tunnels, 70-meter height. These are huge, reservoir type structures where a space shuttle can fit inside. And 6.5 kilometer long tunnels are connected to this reservoir, and the height is about 70 meter, and it has a width of 30 meter. And what does it do? During flood seasons, all the excessive water from the rivers are being pumped into this reservoir. And look at this huge size. You can compare the size of these men with that of these pillars. It has each structure has about 59 pillars, each weighing 500 tons. So it is definitely a very huge structures. And what does it do? During flood seasons, it diverts the excessive water inside this reservoir, and thus controlling the flood. It's all underneath the ground, and during drought seasons, through these canals, interconnected canals, the water from the reservoir is pumped into the river. So this is one engineering technology. No doubt it is it's a very costly affair, but can we come up with cost effective or structures, something resembling this, not such huge structures, but something related to this? It is considered to be an engineering marvel of Asian countries. And talking about engineering marvels, and the transportation sector also, they have come up with new innovations. This was, I think, this came up in 2008, long before all these disasters start to happen. This is called as scuba. SQUBA, scuba, and this was invented by a company, Swedish company called Rinspeed. So it is called as Rinspeed Scuba. This is the first car, electric car, which can run both in water and also on land. And this, I think, the best innovation prize went to this innovation in 2008. But I was wondering that we have long before invented such vehicles which can run both on land and in water. But we are yet to receive any innovation prize. And Mumbai, even the trains in India, they run on water sometimes, especially during heavy rains. So we are yet to receive any prize for that also. And Kerala, we all know that we are quite vulnerable to floods. We have become quite vulnerable to floods because of rapid urbanization and unscientific development and lack of land use policies, because wherever you want to construct, you can construct. There's absolutely no rule or regulation which controls, except in the case of paddy fields. Not much of regulation is being implemented, especially because we don't have a land use policy. If we have had a land use policy, then it would have been demarcated that you can construct only in this area, and you have to retain these many number of green spaces in a city whenever you are planning a developmental activities. But there is no such regulation. We are yet to witness such revolutionary changes. The need for planning when we use natural resources is well exemplified by Uganda. Uganda is a small country, African country. They are very economically poor country, and how they utilize, how they plan to how they utilize the planning process to utilize the existing natural resources to the extent of possible in a judicious manner. It is a small country with 780 million people, no access to clean water. I mean, very limited access to clean water. So they needed to preserve whatever little water is available. They needed water for hospitals, schools, offices, households, etc. So what they did is that in all the hospitals, in all the schools, in all the offices, in all the households, they they went in for a planning process. Like for example, in the school, all the students have to carry a jerry can, 2 jerry cans weighing 10 and 25 liters. Weighing 1 kg and having a capacity of 10 to 25 liters for their all the activities, for their for going to the toilet or for drinking purposes, washing purposes, so on and so forth. Each student is carrying a water jerry can to the school, and it takes them 1.5 hours for them to walk up to the stream and then carry these jerry cans and walk 1.6 kilometer to reach to get the water and then back to come back to the school. And this weight, that is carrying this 25 liters of water, is 50 to 80% of their body weight. Look at the amount of planning and details that they have gone into. Time loss is 165 hours per year per student. So this much of time can be saved if they have something very, some structure containing water very close to the school. What they did is that they constructed a ferro cement tank near the school, inside the school premises. And they have a lock also here, so that water can be used only when it is needed and no leakage will happen. Where does this water come from? It comes from roof water harvesting. So all the roof water goes into this ferro cement after cleaning process. There are some layers here which cleanses the water, and purified water is available through this pipe. And I was just comparing this African country with our Indian situation. Kuttippuram is a mining affected village in North Goa. This was the original scenario in Goa. And this is after the mining of iron ore. Iron ore, it's open cast mining, and the whole topsoil has been removed. And what happens is that the whole process has left this area totally devoid of any water. Groundwater is not there, underground water is not there, and surface water is also not there. And people have to depend, and all the silt from this mine. Silt means very small particles, sized below the sand size. Very smaller than the sand. Those silt particles have accumulated in the nearby paddy fields, bringing down the food production, and people are actually suffering from shortage of food and also shortage of water. And each household will have to they have to keep huge cans outside their houses to get water. And in Kerala also, after the 2018 flood, lot of topsoil has been washed away, and most of the water level has been reduced from 0.25 to even 9 meters down. They have gone down from the surface level. So the groundwater estimate, it shows very clearly that it is going down and down, all the groundwater available, because of lot of concrete structures have come up. And many other countries are, coming up with innovative methodology to conserve even droplets of water. And people, they used to carry water in pots, carry it on their head, and then walk miles and miles. And lot of water will be spilled from the these earthen pots or plastic pots. So United Nations, they have invented a water wheel, which is very easy to carry, and they just can roll it along, and they can even hold on to their babies on their, hold on to their babies with them. And I was wondering why we might have seen water tanks, tankers running helter-skelter during drought season in Kerala, and lot of water is being spilled, onto the road. And but on the same side, if you look at the milk van, a van containing Milma packets, or maybe the milk storage vans, not much of milk is being spilled out. It is because of the design, special design of the milk van, and the lack of that design in the water tank. This is a water tank, a lot of water is being spilled. And Hyderabad, they had conducted a study as to how much water is being lost while the water tankers run on the road. They have calculated that around 20,000 liters of water is being lost per day. Whereas if you're talking about the milk carrying van, this kind of spilling is stopped by these partitions. And some kind of similar things can be tested here also, but we seem to be Keralites in general, we are quite content that under the wrong contention that we have plenty of water to deal with. So we need not to worry about any such loss of water. I think we need to start looking apart from the construction field. We need to look at wherever it is possible to conserve water, what are the different options of reusing water, so on and so forth. And Keralites, the height of literacy in Kerala, if the policeman asks what is the matter, then even any person on the road, they will start to say the matter is anything that occupies space and has mass. And this is a troll, a cartoon which was being circulated some time ago. And Keralites are not lagging behind in ideas also. I mean, during COVID, they come up with this is the typical. This has become the typical Kerala food, parathas. So the paratha, what is this mask-shaped paratha, became so viral in Kozhikode, and it became quite viral in social media as well. But we seem to be lacking in so many things, especially in the when it comes to conservation of natural resources. We seem to be totally lacking in water literacy. Even though when it is standing at stationary, this position, this even when it is stationed here, the water is leaking out. So much of water is being lost here. So can we not come up with, because engineering field is something which deals with the technology part, and research and technology, they have to hold hands together to come up with solutions for this kind of various issues. And we also need to look at the policy aspects. We can't be expecting that we can't sit idle, thinking that we need to look only at the engineering solutions or technological solutions and not at the policy aspects. So, as citizens, I think we need to start pressing for such or demand for such policy initiatives as well. The Paddy Field Conservation Act was, I think it originally came in 2008, but it was amended during the last ministry's tenure, and paddy fields have come down from 9 lakhs to 2 lakhs. And we know that even when we are procuring rice from Andhra Pradesh or Telangana, we are we have to spend water equivalent to 10,000 liters of water. I mean, it is being all the fuel that is being used in transporting and all the water that is being lost when we convert these paddy fields into built-up land. These are all being taken into consideration to arrive at this figure. So I think we need to, whenever we are constructing a structure in the hilly terrain, we need to remember that the topsoil has already been eroded, and there is very little chance of water seeping down the ground, or groundwater storage is very, very limited. What we need to do is that whenever we are coming up with any construction project, just like what they do in China, they are constructing forests in cities. These are called as forest cities. And by about 2030, China is planning to make 30 such forest cities. And we know that each sapling, each tree or plant can absorb water 96 times its mass. So much of water, being absorbed by plants or trees planted along all the available spaces in the flat, they will absorb more water and leaving only less water on the road. So this is a way towards controlling the flood. And they also have come up with the idea of absorbent roads. This has been tested in many other countries also. All the top layer of the road is, that they use permeable materials, so that as soon as it rains, most of the water gets just absorbed into these pervious surfaces, and thus control of flood is also happening. We know that we have had heavy wind and storm surges in the past. Every year now these cyclones are happening, and earlier it was concentrated only on the eastern side of India. Now we have started to experience on the western side of India also, and especially in Kerala. This was the earlier statistics. Now things are almost on an equal ground on both the eastern side and also the western side. Kerala has the highest number of eco-sensitive zones in India. So we have to, whenever we are constructing, we have to always remember that Kerala, India as such, I mean as a country, is very, very, very vulnerable to sea level rise. It is to the IPCC 6th report says that 36 million people will be affected by sea level, and a sea level rise, which was earlier 1 in 100-year event, will happen, will get itself transformed into an yearly event. Every year sea level is going to rise, and Kerala is very, very vulnerable because 12 to 40 centimeter in 80 years, that is the prediction that it is being given. So what is the role of engineers here? Taking into consideration the cyclone, possibility of cyclones, possibility of flood, and possibility of the heavy wind and storm surges or rising sea level. We need to come up with some structures to resist all these impacts. And people by and large suggest constructing a building on pillars, be it a wooden pillar, stilt, or any concrete pillar. And I think in rebuilding Kerala, here also after 2018, the suggestion is to build houses on pillars. But we also have to remember that this is the earthquake map of India. Highest earthquakes are expected in these red colored zones, and slightly less intensity earthquakes are expected in these orange colored zones, and slightly less intensity compared to the red zone, slightly lower intensity earthquakes are expected in these yellow colored zones. And yellow colored zones means zone 3. Zone 3 means earthquake of 6.5 Richter scale magnitude can happen in all these yellow colored areas. And we just look at this map, entire Kerala is falling in zone 3. And some people tend to think or propagate the idea that Kerala is not very earthquake prone because it falls in zone 3. But on the contrary, an earthquake of 6.5 magnitude is expected here. 6.5 is quite a very powerful earthquake, because in Latur, you might be remembering that in Latur, Maharashtra, it's a small village in Maharashtra, a 6.3 magnitude earthquake happened and thousands of people were killed, and lot of damage also happened. And in fact, that is the earthquake which triggered us to think about earthquake resistant structures in India. So this is a very powerful earthquake which is likely to happen in Kerala. People who tend to say that this is not very powerful or very damaging, sometimes they might be ignoring the fact that we have not gone for any microzonation, because this is a very macro zonation level map, and Kerala is marked as zone 3. But if we go for microzonations, Kerala has got n number of multitudes of fault lines where and lineaments. These are all fractures and fissures within the rock crust, Earth's crust. So these are all very potential areas for increasing the damaging impacts of earthquake. So whomever is saying that Kerala is not vulnerable to earthquakes, we need to ask them to answer the question whether we have gone in for a microzonation yet. Because all these assumptions that Kerala is risk-free compared to earthquakes is based on a macrozonation scale, where this map, for example, it might have been prepared in 1:1 million scale or 1:50,000 scale. 1:50,000 scale means a 500-meter area is condensed into one single point on the map. That will not give any details. So if we have to go for any serious study about the earthquake vulnerability, we need to go for microzonation at 1:5,000 or maybe 2,000 scale. That is what we need to do. Anyway, so what is required of the engineers, the responsibility lies with the engineers, is that when we construct these buildings on pillars to resist the floods, we have to remember that these are called as soft storied buildings in earthquake engineering. These buildings which are constructed on pillars or soft story buildings will be the first to collapse in any earthquake. That is what had happened in Gujarat or elsewhere, wherever it had struck. All the buildings on pillars would come down first. So there are various options to improve the strength by retrofitting these buildings. Like once the building is built, we can reinforce or strengthen the frame by providing a steel frame here and increase the strength. But the best option is not to go for soft-storied buildings in Kerala because of the high probability of earthquakes. And we are, vulnerable to multiple disasters. So we need a multi-disaster resistant construction, be it, these earthquakes or flood and cyclones. India is yet to come up with such a design. It can either the building designs provided by Government of India will either cater to flood or to cyclones or to earthquake. It will not. They have not come up with. We are yet to come up with a design which will cater to, which will prevent multiple disasters. And there is a seismic building code 1993, cyclone code in 2004, but multi-disaster. We are yet to come up with a building code. We can start experimenting with, these designs. I think we need not wait for any government initiatives. Why not we start experimenting with designs? For example, this is not a multi-disaster resistant design, but it can actually be used during flood seasons and also in other seasons. Mandroturat is an island in Ceylon, which is going below the sea level. It is slowly, getting submerged below the sea level, and the houses in Mandroturat Island is also undergoing this compaction, and they're going down. So this is a new concept. This is a concept which is being experimented there. I think Barton Hill Engineering College in Trivandrum, they have come up with this idea. They have, emulated the amphibian houses in, I think in Switzerland or Ireland. I'm not very sure, but this exists in some of the West European countries, this concept. So what they do is that they have constructed in such a way that during flood seasons, the entire house will float on water, and after the flood water recedes, the house will sit back on the ground. So this can actually cater to both earthquakes and also the flood. But we know cyclone resistance has been incorporated. And cyclones, we all know that possibility of damage is very, very, very high, especially in the construction center. And we need to come up with alternative building materials also, because we know that these are very, very limited resources. It takes 50 lakh years for the rock to form. 50 lakh years. It's not in our lifetime that we see such a formation. It takes several such lifetimes to actually see the rocks forming. And then the rocks take about 4,000 to 3,000 to 4,000 years to get converted into sand. So these are all very precious materials. So we need to prioritize our building requirements. And we need to go in for alternatives for sand, because we don't have that much of sand resources. This is one option which we can think about. Like India is producing 6.6 to 6.5 million tons of copper slag. This is a byproduct in thermal power plants. Looks almost similar to sand, only thing is that it is black in color. And this copper slag, we are producing a huge amount every year, and this is being now sent or exported to Singapore for building their roads. They use it with tar, mix it with tar, and make beautiful. Singapore roads are considered to be the best in the world. And Central Road Research Institute, if you visit their site, you can see a number of options, alternative suggestions for building materials. And Singapore roads, the raw materials we are sending to them. And what is the status of our road? UN has identified our country as the country which has the largest number of potholes on the road, and maximum number of holes or depressions or potholes on the road. And there is also another study in UK where they suggest that waste plastics can replace sand in concrete. This study they have conducted in collaboration with Goan Engineering College in Goa, and this article was published in the Journal of Construction and Building Materials. So waste plastics can replace sand in concrete to 20%. This mixing is possible. 20% of sand requirement can be shortened, reduced. And construction and demolition waste also can be used for reused for building, which is rarely done in India. And this is just this figure is applicable to Delhi alone. In Delhi itself, or alone, 15 lakh tons of these demolition waste is being produced every year on an average. And recently in Kerala, also in Maradu flat, it was demolished, 300 flats in one go. Everything came crumbling down. And what happened to those waste, we are yet to know. We do not know. It might have been dumped somewhere. I don't know what it was used for. But this can be reused for construction. This could have been reused. That is what it is. It is not I who is propagating this idea. Central Road Research Institute, it's a central government institute. They have come up with this idea of reusing construction and demolition waste. And another option is, I think the CRRI doesn't speak about this option, but in most of the Asian countries, they use bamboo for building. And China heads the list, tops the list in bamboo variety and bamboo production. And we are second in the rank in bamboo. We have about 136 species, and they are yet to be used very widely in construction. Actually, these are all not this design. Any other design would also be can be tested. These bamboo houses are considered to be resistant to both earthquakes and wind. So I think it is time that we start experimenting with these building material. And these are also load-bearing structures in Central America. These are used for construction of bridges. We all know that heavy load, they have to take heavy load, and these have even been tested in constructing the bridges. And we also have to bear in our minds that resources are very limited. So whatever we are constructing, the idea should be that it has to have a multi-purpose, utility. For example, a shelter, a cyclone shelter built somewhere along the coast should cater to sheltering the people during cyclone and during non-cyclone. I mean, when there is no cyclonic activities, it should function as maybe as an auditorium for holding functions or for holding meetings or whatever it may be. Anything that we construct apart from these domestic purposes, houses that we construct for domestic purposes, other buildings should be constructed with this idea in mind, that it has to get to multiple uses. And we all know that 33% of Indians are living in a space less than the US prison. This is a prison in US, in America. They have a TV, they have a ward, a shelf for keeping their towels and dresses. They have a computer, they have a wash area and a nice bed, a pillow, everything is there. And most of the Indians, 33% of the Indians, they live in a space less than the US prisoners. So I think we need to come up with some policy. We need to press the government to come up with policy initiatives. I think it is our responsibility, not only to construct, but also to press the respective governments to come up with policy initiatives also. That the area should be, specified as to how much area can a normal house occupy. Because everyone needs to have at least one house, a roof over their head, and but unfortunately Kerala is yet to come up. I think no state has come up with this kind of regulation, and we are also not different from any other states. And the draft environmental impact assessment notification in 2020 by central government also has diluted the existing regulations to such a level that even 150,000 square meter structure, it doesn't need any kind of environmental impact assessment. And what havoc it can create, especially in an ecologically sensitive zone, ecologically sensitive country like that of ours, especially in Kerala, is, we'll come to know it only in years to come. And there are still millions without a roof over them. So I think it is the responsibility of the engineers and also the geologists or normal citizens to press the government to come up with policy initiatives. And we need to prioritize our requirements. These are some of the developmental activities which still keep worrying the environmentalists from the environment point of view, as to, it leaves a confusion as to whether is this our priority. And recently Wayanad Kozhikode road, this tunnel road was inaugurated at around 10,000 crore has to be spent. No doubt it will ease the traffic congestion, absolutely no doubt. But what impact it will have on the stability of the hills, it will be known within 5 to 10 years. Already Madhav Gadgil has already cautioned us through his report that we are yet to see the impact of all the unscientific developmental activities. I think we are still witnessing that. And we know that cyclones are possible in Kerala, and we are quite vulnerable. And the temperature factor needs to be controlled because as soon as the surface of the ocean reaches a temperature of 27 degrees Celsius. Surface of the ocean gets heated up. As the atmospheric temperature goes up, ocean surface temperature also will go up. So as soon as it reaches the 27 degrees Celsius, it is one factor favoring, or the main factor favoring, the formation of cyclones. So whenever we are constructing, be it a house or any other auditorium or building, we need to keep in mind that the temperature factor is very important, and we need to keep the temperature down to the extent possible. And we all know that concrete structures, they cater to build up all the global temperature. And as if we do not give enough consideration to the environmental factors, the existence of human beings is at stake, because we know that all these construction activities and encroachment activities, it is all affecting the oceans, not only the land, not only the air, not only the these natural resources, but the oceans also as well. And oceans are responsible for producing 1/3 of oxygen, because all the forest oceans do have a forest area underneath under the water. And these kelp forests, these are called kelp forests, these plants or trees underneath the water, they produce 1/3 of our required oxygen. So we get 1/3 oxygen from the oceans, and they also provide 300 crore jobs and provide 6 lakh, generate 6 lakh crore revenue. So, but in the process, this IPCC report is also mentioning that as the temperature goes up, carbon dioxide, these emissions are going up and the temperature is going up. These carbon dioxide, most of the carbon dioxide get absorbed in seawater. 1/3 of all the carbon dioxide that we produce, especially during concrete, when the concrete structure is built, whenever a concrete building is coming up, we are increasing the chances of emission of carbon dioxide or greenhouse gases. And this carbon dioxide is mainly absorbed by the seawater. Carbon dioxide plus water, it becomes carbonic acid, and it is acidifying the oceans. And as a result, all the coral reefs, which these are very important species, which can even stop tsunami or cyclone surges, storm surges, etc. And it sustains a diverse, species of organisms underneath the water. Lot of species they do thrive on these coral reefs, and because of the acidification, these millions of species, they die, and the coral reefs also become just like ashes, and all the oceans are becoming acidic in nature. And we also need to talk about reusing recycling the waste that we produce. We knew that Kerala produces about 480 tons of plastics each day, and these plastic beads or plastic bits are reaching the ocean. 8 lakh crore plastic bits are reaching the ocean every day. In fact, in some of the soaps or soap that we use for bathing, or some of the soap powders that we use for washing our clothes, they also contain these microbeads. To increase the effectiveness of washing, they use, you might have noticed in soap powder, colored particles. These are also small plastic beads. So whenever we are selecting any material buy any soap or soap powder. We have to be environmentally conscious as well, because in most of the creams also contain this plastic beads. They're all reaching the oceans every day, and by about 2030 it is predicted that most of the marine organisms will have these more than 80% of the sea organisms will have these plastic in them, in their digestive systems, and also in their skin, under their skin, in their it will all find its way into the human beings also. So while talking about the role of engineers in all these environmental concerns should reflect in some solutions when we talk about engineering. A lot of innovations are happening with recycled plastic blocks, with 25% of recycled plastics. Some will look like this, and some will not have even the identity of ever having been a plastic. These are all as robust as any other building material, and they have been mechanically tested also. Most of these research is happening in the UK and also in Germany. And recycled plastic bottles are they are using it as building blocks, and there is a chance of being susceptible to fire incidents. So a fire retardant like gypsum board is also used to reduce the fire risk. So things are happening in the world. Anyway, these environmental concerns we are discussing here, so that we find some solution to reduce them. And the best line of defense, be it any natural disaster along the sea coast, we all know that is to retain the natural sand dunes. These sand dunes and these bushes here or small grass here, this offer the first defense in any storm surge or any tsunami, so on and so forth. But what had happened in the recent past is that we have removed all these natural things and replaced them with artificial things. And as a result, the pollution levels are going up. We have in India, we have the most polluted cities in the world, and 15,000 babies are dying prematurely in Delhi because of this pollution, high pollution. And China also is having the same issue of air pollution. And in Kerala, Kozhikode, Kochi, and Trivandrum, they also figure in this hazard, air pollution hazard map. And China also has similar issues, or maybe a larger issue of air pollution, but they have come up with innovative solutions. They have built the tallest air purifier in the world. This air purifier can purify the air in a 300-kilometer wide area, around the purifier. This is the longest. Chinese air purifiers are the tallest air purifier in the world. And we are not left behind. Indians are not to be defeated. So we have come up with the tallest statue instead. We just had to spend 3,000 crore rupees. We are not for any air pollution and air purifier. We, showed the world that we can still build the tallest statue. So I think we need to be concerned about the priorities of our governments, be it our government here, the state government, or the central government, or any other government. I think it is a matter which concerns all of us. We can't just say that it is a matter of, it's a political matter, so let us not discuss about it. I think we need to start thinking about it, voicing our dissent or voicing our support. Whenever nice things are happening, we can support, and whenever wrong things are happening, I think we need to raise our voice equally louder. Because we are talking about optimum utilization of resources, and government, be it the state government or the central government, they are responsible for coming up with policy matters. And we are still in the hunger index, around 119 countries are there altogether. We are occupying the 100th position. That means that a lot of people are still hungry in our country, and we need to conserve these natural resources so that a judicious distribution is happening. And the Central Vista project also, I think, said at the central government level, we are demolishing the existing parliament, and a new parliament house is being built. 20,000 crore is being spent. Tatas have been given the responsibility. These are all concrete structures. So are we adding, we are not using any alternative building materials. We are not using any green building technology. So are we not adding to the global warming or global temperature? I think it is a matter of concern of every Indian citizen. And this is the new central parliament. This is how it will look like. But I think the priority wise, eradication of poverty or hunger, these are all giving drinking water to all. These should be our priority. And engineering community, when it comes to utilization of water, many countries have shown the way as to how to do that, especially in Singapore. The storm water during storm or heavy rain, most of the water will be just running off into the ocean along the road and causing flood. So what they did is that they have diverted this excess of water underground, and through long pipes and drains, stormwater drains, and they collect it in huge tanks, underground tanks. And these are recycled, purified, recycled, and 18% of their water requirement is from this recycled water. And I think we also can do something with our existing drains, and because we can't construct a separate storm drain like this, so there is no space here available because it's a small state. So existing drains, can we do something? Can you come up with some idea to make the water go down instead of concretizing, whether any other material can be used here so that the water will drain down, collect underneath, and then get purified, and then can we reuse this water? So these are all examples of stormwater drains which can cater to the use of these multi-story buildings or flat systems. These are the drains through which the water can go down into these pipes. So these are all possible options. And in Maharashtra, they have come up with a regulation that it is mandatory to reuse wastewater, especially in large industrial units where a large amount of water is being used. They have to compulsorily reuse waste water. And in Bangalore, they also have a system of, it is being initiated to recycle the water for drinking purposes. This is a private company, Transwaters Private Limited, and they are showing the different treatment procedures, and it will be equivalent to the bottled water in quality. That is what they say. This is the original water, and through various processes, they could attain a quality equivalent to the bottled water. So these are the systems established to purify or recycle the sewerage water. Even these toilet water, it can be gray water. It is called as gray water. So we need to come up with engineering solutions as to how we have adopted the European system of European closet, but I think we need to come up with some Indian solution to save water, because every time we flush a toilet, 20 liters of water is being wasted. So I think we need to come up with some solution, and innovation is also required to, because I understand that, or I presume that not only the civil engineers are here to, share in this session, but all the other branches are also, maybe, I'm not very sure, but just as a sounding board, I'm sharing a few ideas with you, that we are yet to come up with a ground penetrating radar or equipment to know whether any life is trapped underneath the debris. In Kerala, when the disaster happened in Pettimudi, this equipment had to be brought in from NGRI. So can we come up with some electrical or electronic equipment to sense life underneath a debris? This might become handy or useful in earthquake, in searching for people trapped in earthquake, these debris or landslide debris. So these are all things which we need to come up with. And the fishermen who saved our lives, they saved so many lives in 2018, but they are yet to get a warning, equipment to warn them of a warning equipment which can be used in natural disasters. This is an equipment which is developed by ISRO, emergency position indicating radio beacons, EPIRB. These equipments, it can be fitted onto the boat, and then they can go into the deep sea. But the main problem with this is that we can inform them if there is anything to be informed, like a cyclone is coming, so please come back. This information we can give to them, but there is absolutely no way that they can communicate back to people on the land. So two-way communication is not possible with this equipment. So if the boat capsizes, or an accident happens, or if some foreign boat shoots at them, so many incidents can happen in the deep sea. There is absolutely no means by which these poor people can inform the people, the land authorities. And these wireless sets have been given by the state government, which has coverage of 20 nautical, which works in 20 nautical miles. But the fishermen are already using mobile phones which can work into 50 nautical miles. So they seem to be more upgraded technologically compared to the government setup. So I think we need to come up with some kind of solutions, because engineers' role need not be limited to construction activities. We need to collectively put our brains together and come up with some solution. We are definitely in an emergency, and both species existence of human beings, everything is at stake, and we are responsible for most of the greenhouse gas emissions. And many people say that, many experts say that we have just 12 more years to save human beings, save ourselves or the world. And per capita carbon dioxide emission is still going up and up. India is responsible, every Indian is responsible per annum 1.5 tons. Every Chinese is responsible for emission of carbon dioxide 3.3 tons per annum, and USA, a developed country, is responsible for 23 tons of carbon dioxide emission. Unfortunately, they don't take any kind of responsibility in controlling this or the global warming. And any summit, any IPCC meeting or Rio summit, be it the Rio summit, it started with 1992 Rio summit, or the major breakthrough was in 1992. But whatever decisions they take, it is non-binding. Non-binding means the decisions taken, it is not compulsory for any country to follow. If you want, you can follow. If you want to implement, you can implement. There is no compulsory. It's not binding on them. So I think we need to start talking about these unjustified, stands by the developed countries, and we need to be prepared as a community, and we need to bring up the capacity of all the stakeholders, including the engineers. We know that due to concrete structures coming up without any policy or guidelines, we are creating an urban heat island, because if it is a natural vegetation, all the solar radiation will get reflected, because there is a lot of open space available for the reflection to happen. In a closed, congested city area, this reflection is not happening in an effective manner, and most of the heat gets trapped within the buildings. Thus, the temperature goes up and up. And in Germany, they are coming up with the idea of mobile green living room. This mobile green living room has already toured. It is on a tour in most of the European countries, and most of the people inside, you get all the facilities, but it's a green living room. Inside you have all the modern facilities, but outside it is all vegetation, natural vegetation. And coming back to controlling of temperature, we need to experiment with many things. This is an experiment which is done by I think UK, and straw bale houses. Straw bale means these straw vacuole in Malayalam. These are used in the construction of walls, and these are later plastered, and it will not have it looks so hygienic and neat and clean that we will not even guess that it is straw bale behind this plaster. This reduces the temperature to such a great extent. So this is one option. And we can even start to experiment with coconut husk or something like that. And we need to use our, in a nutshell, what we have been saying and reminding ourselves is that we need to use our resources judiciously, because we have already crossed we call this as the overshoot day. That means that we have already used up what we can use in an entire year. By July 29th to 2021, we will have already utilized all the natural resources which are intended to be used over an year. Natural resources മുഴുവനും നമ്മൾ ജൂലൈ 29th ഉപയോഗിച്ച് തീർത്തിട്ടുണ്ടാവും. അതിനാണ് overshoot day എന്ന് പറയുന്നത്. So already we are 3.5, we have used 3.5 earth resources, and we can't continue like this, and we need to recycle natural resources. Germany is leading the world in recycling. India at present generates the most waste globally. 77% of waste is still being dumped in open dumps, 18% is composted, just 5% is recycled. So whenever we are talking about disaster management or disaster risk reduction, global warming or climate change threats, I think this is the point that we need to remind ourselves that all these things which are left, 95% of the things which are left unrecycled can be utilized for our building purposes. We also need to convert ourselves as into responsible citizens, because we are using our mobile phones, our internet, and every use of internet, be it on your mobile phones or internet. Of course, now we have no option, but we need to put some control over it, over the data, how we use it. Because every time we go somewhere, we put a picture, we post a picture, and then post it across to our friends, and all this data is creating a carbon footprint. A carbon footprint, internet carbon footprint. Internet carbon footprint means footprint carbon emission due to use of internet. It is equivalent to the entire aviation industry in the world. All the planes, or all the aviation facilities in the world, how much carbon it would emit. This is the maximum polluting industry, aviation industry. How much carbon it will emit, equal amount is being emitted in internet use also. Every time we go to sleep, some people have a tendency to send complicated or complex or sometimes simple, but all imageries, I mean lot of picture messages, a good night at the time when you go to sleep. It doesn't serve any purpose, but still they just send. And when you wake up, you see a bunch of flowers and these good morning messages. And during any festival seasons, it's a flood of such messages. And every time we send these picture messages, remember that somewhere it is all getting stored. Lot of energy is required to store these data. Electricity is needed, and there will reach a time when electricity will not be available for us to for our common daily purposes, because most of the energy will have to be diverted into storage of these data. This is a single cluster in a single floor. Similarly, there are multiple floors, and each of these systems, these storage systems, contains all the pictures that we have sent from our birthday photos to our anniversary photos or whatever it could be. These are all getting stored in somewhere in the world, and this storage is happening in Oregon in USA, most of it, and it has already occupying this office building 323 million square meter space. That's such a huge building. And 1 terawatt energy is maybe required within a few years. That is 10 raised to the power of 12. That is equivalent to 20.9% of the global energy. This may be needed to store the data that we are generating every day. So just be mindful as responsible citizens, not to unnecessarily tax the internet, because by the time this child grows up into a young adult, within 18 years, 20.9% 9% of the global energy would be utilized, will have to be diverted to store all the data that we are generating. So there are various options to self-control to bring about some self-control. These are some of the options that we can test or utilize. Global footprint calculator. This is you just can Google and then keep on monitoring our lifestyle. How many dresses do you have? How many times do you wash them? What kind of materials are you using in your day-to-day life? WW World Wildlife Fund Environmental Footprint Calculator, My Climate Carbon Calculator. These are various options that we can utilize to keep a self-control, to bring about a self-control. Individual level, we have to take stern, very firm decisions not to add to the carbon footprint. No tiles, please, at our house premises, because it adds to the flood, it adds to warming up, increase in temperature, and nothing which result in cutting of the trees, cutting down the trees should be used by us, especially the paper napkins. Instead, we can use a simple handkerchief, and all the plastic pens. These are simple things that we can do at an individual level. Plastic pens can be replaced by ink pens. So these are individual things that we can do. 30% of the forests, if we restore, we can save 70% of the species from getting extinct, and it will also save in absorbing half the carbon dioxide emitted since 1760. So I think we need to remember this, that an irresponsible throwing of a plastic straw can create to a wild organism in the sea. This is a sea turtle, and a plastic straw inside its nostril, and these environmentalists are helping the straw to get the straw out from the nostril. I think we need to remember that whatever action that we do, there is only one Earth, this whole universe that we know about. There are about 100 billion galaxies. 1 billion is 100 crores. So 100 into 100. That many number of galaxies do exist around us in the universe, but we belong to a small galaxy named as Milky Way, and Earth is the one and only place where we tend to notice life. So I think we need to live responsibly and act responsibly so that we can bring in a better future, and we can prolong this deadline of 12 years to maybe with our responsible actions we can try to bring about peace and prosperity amidst ourselves. I think I'll stop now and leave the floor for any kind of questions.
Thank you, ma'am. Now it's time for question and answer section. So participants can post the questions in the chat box.
I'm not able to see the chat box right now because I think it got hung. Somehow it got hung. So
Ma'am, I'll read it for you. No problem.
Please. There was some technical problem and I just got logged out.
Okay, ma'am. Okay.
And the presentation also got hung up. I think there were just 5 or 6 more slides left. So did anything happen while I was out? I mean, did anyone ask anything or?
No, ma'am. No questions were posted. So, ma'am, thank you so much. I would like to express my sincere gratitude to our speaker, Dr. Tara ma'am, who shared her thoughts with us. Ma'am, your session was really informative. You have explained so many ideas followed globally for a sustainable society and which can be followed in our place also. Like new designs, planning, alternative material usages, etc. But why we are not practicing it is a big question. Let it be there. Then your session was really motivating also, ma'am, because as an engineer or as a citizen, it is our responsibility to respond to this current issues responsibly. I wish all the participants get benefited in such a way that they can act responsibly against these challenges. Once again, thank you, ma'am, for joining with us, sparing your valuable time and sharing your experiences. Thank you, ma'am. Thank you so much.
Thank you so much. Thank you so much for this opportunity. And I would love to get feedback from you. I'm not able to access the messages right now. So if there is anything to be shared, please don't hesitate to share it with me. So thank you so much.
Sure.
Okay, thank you, ma'am.
Thank you.
Thank you, ma'am. I request all the participants to fill the feedback form. The link of the same is shared in the chat box.
I'm just trying to log out. It's not permitting me to log out. Okay, so I just have to switch off and then leave. So, bye.
So, may I remove you, ma'am, from this?
So, no, I can switch off, no problem.
Okay.
I got from somewhere.
That's the end of today's program. Hope all the participants have filled the feedback form. Thank you all.